Hello everyone, and welcome back. So in today's video we are going to be continuing with our series. So we were trying to build a machine learning project that was all about predicting electricity bill. So that was our project, and we were working on it, but I think we had reached first, I think model trainer. But along the way, I encountered some troubles or some challenges with the entire code, and so it made me to try to debug the code and try to find the challenges or the problems with that. And so in the process, I decided just to drop everything and try to start afresh and try to correct the mistakes and try to present the code in a more systematic modular way. So I was able to achieve that, and I'm going to be showing you how we can correct those the challenges so that in future you might not meet, or if you encounter a challenge, you will be able to solve that. So this will be a little bit an upgrade of what we were doing in the previous videos, but it's not that really complicated. I hope you will follow through. And before we get started, if you're new to this place, or if you're a fellow data scientist, please consider subscribing to this channel. We are welcoming you to this wonderful community. Hit that notification bell so that you never miss any of our video updates. From now henceforth, I will be trying to doing this end-to-end machine learning project, starting from building or the scoping part, the building of the model, all the way up to deployment, and possibly introduce other tools that are necessary in terms of building a machine learning a model, deploying it, and ensuring that it is correctly working in the field. So that's what we are going to be doing. So I'm going to start with the supervised learning, machine learning algorithms. Then in future, we can go to the deep learning algorithms, see how we can apply those into natural language NLP LLMs. Okay, so we are just going to start small, but add the skill as we progress forward and forward. Okay, so so with that, with all that said, so let's get started. So for the project, we're going to start. So I'm going to set up a GitHub repository for our code. So this will be GitHub will enable us to manage that. It's a central repository that will enable us to share this code with you. So I'm going to create a GitHub repository for this project. So you can just create an account if you don't have an account for GitHub. So just create an account and it will get you to this page. That is for the those who are new to this section. So create the GitHub, then it will bring you to this place. And once you're at the dashboard like this, you can just create new, and it will create a GitHub repository. Then from that, we can just create repository name. So mine is electricity bills. Then with this, I'm going to for the electricity. Okay. My repository name is electricity bills. Then description will provide that later. So I want my repository to be public. So if you want yours to be private, then you can click private, but I want mine to be public so that I can share with you. Then after that, I can just add a README file. You'll see the usefulness of having a README file. Then I will add a git ignore file. So I'll specify the programming language that I'm using. So I'm using Python. Then I will also add a license. So GitHub advises you to include a license in your files. So I'm going to use, you can use any, but let me use MIT license for this. You can use Apache or any, depending on your choice. So after doing this, you can just create a repository by just clicking the create repository button. Then after you are done with that, this is the repository for this project that we will be doing. So once you have created your repository, then the next thing is all about cloning this repository to folder to your local machine, because they have to be working in tandem. Okay, so I'm going to show you how you can clone this repository to a local folder in your local machine. So I've created a new folder. You can see MLOPS projects. So this is just a new folder, and I'm going to copy the link of this folder. So once you've copied the link, I'm going to open the command prompt, so cmd. So with the cmd, you can open the command prompt, and from this, we are going to now, it will enable us to clone that repository. So my folder is in the E drive. So in the E drive, you can just say cd and then just paste. You can see I've just pasted cd, so something like a command. Then we copied the file path, so I've just pasted the file path for that. When I execute enter, then from here, this is now when we do the git clone. So I'll just say git clone. Then when you type in that command, then you can just go back to your git repository. Then under this code, you can just copy this link. And once you're done with that, you can just go back to your command prompt. And after the git clone command, you can just paste your the link itself. Once you execute this, you can see it's cloning into the this repository. So I think this is okay. I think we have cloned our repository. So I'll just do clear this. Then I'll just close this. So you can see the MLOps project, you can see the electricity bills folder. We have created a folder for that. And when you open this folder, you can see the files, the gitignore, the license, as well as the readme file. So once you have done with this, then we can open an instance of the VS Code. So you can just, again, use the command prompt. So for the command prompt, you can just type code dot. So code dot, it will open a new instance of a VS Code. So for this project, we're going to be using the VS Code. Okay, we'll just do CLS and close this. So we will be using the VS Code for this project. You can also use any other IDE. I like Visual Code because it's lightweight. So after this, you can then open that folder that we created. So mine was in the new folder E drive, MLOps project, and this is the folder itself. So you can just open that, and when we open that, you can see that directly we have see that we do have the folder itself. So you can just say I trust this author, and that's okay. So once you're done with that, you can see that let me try to so we can let's say settings, can use the zoom. So zoom the font, so that's okay. So I'm just trying to zoom so that it becomes visible for you. So once you have done that, then the next step will be all about creating a virtual environment. So I'm going to create a virtual environment. With this virtual environment will enable us to run or install the necessary dependencies for the project itself. For example, if you want to use the pandas, those libraries, the scikit-learn, XGBoost, if you're using the XGBoost supervised learning algorithm, so you need to first have a virtual environment, and this virtual environment will enable you to install all the dependencies for your project. So I'm going to create the environment for that. So I'll just say conda create minus -p venv. So venv is the name of the virtual environment actually. So I'll just specify Python version 3.11. Then I can just use a notation there. So so that after retrieving all the files, the notation it will just install them. Okay, so you can just install that. So as you can see, collecting the package and metadata and everything. So while this environment is being created, we can just create a new file here, the template. You can just say template.py file. So we are having a challenge with this. Environment, okay, so it's okay. Don't know why I'm getting this problem, but anyway, you can see that it's being installed. So no problem with that. So anyway, as this is taking place, so we'll just get a notification that will tell us that we have successfully created the environment. So as this is continuing to do that, I just create a new folder template.py. So this template.py, we are going to create the project structure, and we are going to use this to create the files and the project structure itself. So the necessary files that are will be needed for our project, as well as the folders itself. Okay, so we can create them individually one by one, but I think that will take a whole lot of time. So let's just create a template file, then specify the file names and the file path, as well as the folders themselves. Then with just one command, we can execute it, and it will create those files and the necessary folders. Okay, so we'll just wait for this to complete as we create the template.py folder. So we'll start by, so I'll be using comments to enable you or to guide you as we progress with this. So let me just again, so say import the necessary. So we are going to first import the necessary libraries. So libraries. So that's okay. So I'll import OS, and also I'll also import the pathlib. So import pathlib. See, we notice can say yes. So import pathlib. No, from pathlib. Supposed to be from pathlib. Import path. So with this code, we'll just do the hard coding part. So I want so then define the package name. We are going to first define the package name, and for package name, we can say so package underscore name. So I'll just specify the name of this. Let's say electricity bill. That's the package name. So I think this one is done. You can see that to activate this environment, you can use this. So I'm just going to copy this command and just paste it here, and it will, when we execute this, it will activate this environment, and you can see we have the venv, something like a folder that is being created. Okay, so this is the venv, and with this, it's basically telling us that we have created our environment. So that's all about creating the environment. So let's proceed. So package name, electricity bill. Then we can list. So list the files to be created. So we are going to list the files that will be created, as well as the folders themselves. Okay. So let's start here. Then so let's do list underscore of files. something like this is a dictionary, a list. It's a list. So path. So dot GitHub. Then workflows. That's correct. So workflows. Then you can set this. You can say dot git keep. So this will be essentially this will be the GitHub workflow directory. I can just close this. This will be the GitHub workflow directory. Then after this, we are going to start with the source folder, that will contain all the source code. So you can say SRC. So SRC is just a short name for source. So you can say the package name. So package underscore name. Then okay, that's okay. Then for the first file, we can say underscore init underscore dot py. So when you use the init underscore init, when you use this file, it means that we are telling Python that this source code, this folder can be used as a package, so it can be imported into another file or folder. Okay, so that's that. Then you can also create another so src, so hyphen, then package name, name, and you can just do the same thing. So we are getting the first folder under the source. So src is a general folder, and under this, the src, we are also going to have different folders that will be having different files. The first folder is the components folder, and under the components folder again, since you are creating a folder, you need to use the init.py file to ensure that the components folder will be regarded as a package itself. So under components, remember we do have different for a machine learning system. We do have different components. We have the data ingestion component. We have the data ingestion, data transformation, data validation, the model trainer, the model evaluation. So we do have different components. So all those components will fall under the components folder. So for example, the first one will be, we're just going to repeat the same thing until here. So I can just copy this and paste inside. So the first file under, it will be a py file. So I'm going to create under components, I'm going to create the, so we can say c underscore 01. So component number 1, which is data ingestion dot py, c underscore 01 data ingestion dot py. We'll also create also another one will be, I think I can just sign into tab 9. So tab 9 is just like a GitHub Copilot. They're just working almost the same. So I just want to ensure I've logged in. So for this, you can just again copy this, and so data ingestion, data transformation. Okay, so C02, it will be data transformation .py. So C component number 3 will be data ingestion, data transformation. You can also say this one, let's say this to be C03, and this one C02, it will be about data validation. So data validation.py. So you can just copy this. So 1, 2, 3, 2, 3 key components. So C03, C04, data validation transformation. Then we can also add a model trainer. C03 model trainer. So component number 3, you can call it model trainer. So, and any other you can just add from this place. So let's for another, you also have another folder, which is the utils folder. Utils folder will contain the utils folder usually contains the common tasks that our project will require. So those common tasks, we just save them under the utils. So you can just say utils, and since we are creating a new folder, we need to also include the init _.py. You can just say init _.py. So that's okay. Then the utils will contain, you can say, the commons folder. So you can just create a new folder, utils, and say commons. Commons.py, utils common.py. Okay. We will be setting up our configuration. So again, we set a new folder, config. So all our configurations will be under this folder. So again, init.py. And then we can just copy this again and say configuration. So configuration, that's okay. Another folder will be about the pipelines. So we can say the pipelines. So initially we do have different pipelines. So we can have the data ingestion pipeline, data validation pipeline, and all that, and so on and so forth. So for the pipelines, we need to create that. So pipelines is a new folder. So pipelines is a new folder. So we need to include the init.py. Then we can create, we can just do away with this. So pipelines. Then we just create a first pipeline, let's say P01. We can say before the data ingestion. So pipeline number 1 will be for data ingestion. Let's say pipeline number 2 will be for, let's see, you can just, pipeline number 2 will be for data validation. So that's okay. And so on and so forth. So you can just add those. Let's add the last one. So for pipeline number 3 will be for data transformation. That will be pipeline number 3, data transformation. So data transformation.py. So you can add the rest. So after the pipelines, we do have some, we'll be having some entities. So again, for the entities, you can just copy this code. Again, just paste it. There's a C package name, so entity. So for the entity, you can say, since it's a new folder, init.py, then you can copy this. So for the, again, entity basically will contain the configuration entities. So config entity .py. So we can just say configuration entity. .py configuration entity. That's okay. Can also create another folder for constants. So again, can just say this package name constants init.py. Another one constants, so not init.py. Init.py. We can also, if you can have the exception, exception.py. Also, you can have the logger src. I think it just be the same thing. So let's copy this. Then you can say logger.py. Exception. Okay, so other files, you can have other files include the YAML file. So config, so config.yaml. So this one, from here you can see that we are not including the package name. So this won't be contained under the package name, which is the electricity bill. So this will be contained outside the source code folder. Okay. So for the params, YAML file, you can also have schema. Schema.yaml. So you can see some additional things that have been including in this folder. So you can also have the main.py file. So with the main.py file, it will be a central place or location where we can just execute our entire code. Although I will also set up, you can execute the individual components. So I'll make sure we execute the individual components, and we also have a place where we can just execute the entire code itself. Okay, so that's the main.py. We can also, we are going to create front face, and that will use Flask to create a simple web application. So that will be the app.py. So app.py. Also we have the setup. So the setup.py. Where we setup.py. In terms of the requirements, so the requirements.txt file. It will contain all the dependencies for our project. Requirements.txt. We also create another file, which is the research. Let's say tribes. Research, or say let's just use research. 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 Inside here we'll have trials folder. So trials.py, and then the research. Then we have the templates folder. So templates folder. Under the templates folder, we'll have home.html. We will also have then templates. So templates, here we also have home.py and the index index.html. So another thing, I don't think if we do have another folder or file, we'll just include them where necessary. So I think this one we are done with it. So templates, research, okay. So we write something below here. So when creating the list, we are going to loop through each file the list so that we create them. So for file path in lists underscore of files, list of underscore files, we are going to loop. So file path file path. Then now we can say sorry for that. Then now we can say we are going to split the file path into a directory as well as a file name. So for this, you can just say file directory, split that, and also the file name. Say os.path, specify os.path split file path. Then once we are done with that, we are going to create directories if they don't exist. Then you can say if file directory does not exist, or if it is something like empty that does not exist, then we can say os dot make the directory itself. Make this, just say file directory exist underscore okay to be true, supposed to be a comma, exist to be true. Okay, then here we're just going to create an empty file. So if it doesn't exist, or if empty. So remember, we are going to use the for loop to loop through the list in the files as we create those files. Then we need to be specific because we do have a file path and just a file name. So we have to split that. So split the file path into a directory and also a file name. So we are using this. Then create a directory. Directory is like a folder. So if create a directory if they don't exist. Okay. Then we create a file if it does not exist or it's empty. Okay. So if not os.path.exist path or os.path.get size file path. or if the file path of the necessary file is 0. Now the file size, dealing with the file size, then from there you can just say with open file path supposed to be open file path. Okay, so that's okay. Then just say pass. Okay. So this is how you can just create these files and the folders themselves without doing them manually. So after we are done with this, the only thing that we can do is just go to a new terminal. So let me try to zoom in. Then we can just open a new terminal. Under this new terminal, you can just say Python. Then we have the templates, template file. So Python, you can just say name the file. So Python template.py. So let's see if everything is okay. Comma. Make sure you have these commas at the end of each line so that it's able to specify the different files. YAML, py. Okay, so I think we're okay. Comma. I think we're okay. So when you enter, you can see that we can see now on this side you have the GitHub, the config. You can see config YAML. For the research, you can see you have the trials.py. For the SRC, you can now see we have the components folder with the necessary files. You can see we have the config with the necessary file, the entity. You can see the constants, everything. Okay. Also, the SRC folder itself, it does have the I think the utils. We created a utils file. This is the utils file. The electricity bill we did not create, so we need to create. Just wait a minute. We need to have, I think the SRC folder should also have a utils file. Okay, we need to create a utils file for the SRC folder. This will just do it manually. We forgot about it. So for the SRC, we need to create a new file and say init _py. This file already exists. Let me see something. I think it's okay. Or we need to create one for the utils electricity bill as a folder, as a package name or a folder. Let's try that. So utils underscore init _.py. And see it also okay. SRC package name. What if we of this can start, let's try something. Can start with the instead of the package name, do this src init.py and try to execute this again. So Python, let's save this, control save, and just do this again. So when you do that again, now you can see, yeah, now it's okay. Now the src as the source code itself, it has the init.py. That means it will be accepted as a package, and the electricity bill, again as a package, it also has its own, the init.py. So I think we are okay with that. So after we are done with this, we can then push this to our git repository. So you can say git add dot. So git add dot adds all the file. But if you just want to add one file, you can say git add and specify the name of the file. So git commit, you can do git status to see which files are we pushing. So these are the necessary files we are pushing to GitHub repo. And then after this, we can say git commit minus m. Then insert a message. You can say project files and folders. Then after git commit, we can do a git push. So git push minus u origin main. When execute that, we'll push these files and the necessary folders to a GitHub repository. So once this is complete, you can go back to your git. When we refresh this page, you can see now we have our files, the necessary files and the necessary folders. Okay, you can see this one 30 minutes ago, this one now. Right, so after this, let's now I can just do away with this. We have our template, no problem. We have created our environment, no problem. So the next thing will be about the setup. So let's create our setup first. Let's create our setup.py. Then we install the necessary libraries, possibly maybe create or first create the logger, maybe the exception. Then you can see how we can proceed from there. So let's create our setup.py. So the setup.py, so start by importing the libraries. So the setup.py, I had a folder somewhere that can easily tell us the necessary things with that. So let me see if I can get it. Okay. Documents. You can just search for it, but in the process, let's put the necessary libraries. So from setup tools, import find packages, so that's the setup. Then from typing import list. Then you can go and create some, let's say, version for our code. So version underscore, and specify this to be 0.01. So version 1, then src source repo, src. So I think this is the repository name. Repo, can just say electricity bill. electricity bill. You can then do the setup. So setup. For the setup, we do have things that we need to include. For example, the name of the code itself. So you can say name src repo, and can also include the version. So with the version, we can say what we created earlier. So version. Okay. We can also add description. So for the description, and say this is a project to predict household electricity bill. Okay, so that's it. So another thing you can say the author. So the author, I can use my name. So my name is Western. So that's my name. So author email. Email, you can use uniqueworks email. So another thing we can use packages. And say find the packages. Pages like that. And from here we can also install the requirements. So for the requirements, this is the place where you are required to provide a list of the requirements. But I'm not going to do that. I'm going to list my requirements in the requirements.txt file. In the requirements.txt file, and create a function that will read the dependencies from the txt.file and install those directly. So possibly in different projects you do have different types of dependencies. So listing them here won't be conducive for that. So you can just create a new file for that and list all your dependencies in that file. That for our case, that is the requirements.txt file. Then after that, create a function, read those dependencies, and just install them from there. So we can just create that file. So we can say get requirements. So this will come from the requirements.txt file. So to be version. Okay. Another thing, I'm supposed to like that. So get requirements. So we don't have. So we create a function for the get requirements that will read those requirements. So def get requirements. Get the requirements. So file underscore path, so the file path. File path str no. So the list is supposed to be this one. So list, so that is it. And then create an empty list, so that will store the requirements like that. And with open file path, let's say with open file path as a file underscore obj as a file object. Then do requirements file underscore obj. But we are going to read the different lines under the in that file. So in our txt file, so read lines, then comments. Then when we are reading those lines, we're going to do some replacement. So we're going to replace a new line with an empty string. This one will be for the requirements in requirements. That's okay. So let's go to our requirements.txt file. Let's save this first. So requirements.txt file, and in the requirements.txt file, let's begin listing the dependencies. So like for example, the pandas, the numpy, and have cbon if you want them, Flask, ipy kernel if we need using a Jupyter notebook. Another file is a Python box. We also use the YAML file, so file by YAML file. I will require joblib. We also need ensure annotations. We'll also need joblib ensure types by YAML. By YAML. Also, we need Flask, pandas, numpy, matplotlib, ipy kernel, Python box, by YAML, joblib, ensure. Let's see if I'm missing something. XGBoost, I don't think. Okay, Flask. It's okay. Matplotlib, cbon. I think we are having that. So, and we need to put this as minus e dot. So I'll just explain you what the minus e dot is. Let's go back to this file. So remember, we have the minus e dot as a requirement in our requirements.txt file. So in the setup, we need to mention that. So hyphen e dot requirement. So that is hyphen e dot. So I'll just explain what the hyphen e dot is in a second. Let's just complete with this. So if hyphen e dot requirement hyphen e dot requirement. So if the hyphen e dot, this one is in our list of requirements, this one here. Okay, so what we can do, if that is in the requirements, basically we're just going to do away with that. So requirements dot remove. We're going to remove the hyphen e dot requirement. So hyphen remove this one. Okay, so putting the necessary libraries, the hyphen e dot requirement. You can see this is this one. So let me save this. Then let's execute this, and then I'll inform you about the necessary files, why we are using different files and all that. Okay, I think this one is okay. It's okay. Install requirements. It's supposed to be install requires. Get requirements. So this function should be this. Then requirements. Requirements.txt. So I think that's okay. So I'm just looking to ensure that everything is okay. So from setup tools, import find packages. Setup from typing import list hyphen e dot requirement. Get requirements file path string. This becomes a list of strings. Okay, the requirements. So open this file path. So requirements dot replace the new line. So the new line character with an empty string for requirements in requirements. So that's okay. If this one is in the requirement, you need to okay. So I think we are good with that. So let's install the dependencies. So for the dependencies, we can say that what am I missing? You can just open a new terminal, and from the terminal, we are going to install the list of requirements. We can just do the pip install -r requirements.txt. So let's install those requirements. Pip install -r requirements.txt. So as these files are loading up, let me inform you of those necessary files. So machine learning project files, all that. So we did have the setup, so we can know the setup.py file is used in the project to define how necessarily the project should be packaged, installed, and distributed in different environments. Under the setup file, we define the metadata, the name, the version, author, and all those, the description of the project, and all that. So that's under the where we define our metadata. You can also specify the dependencies, the scikit-learn, and all that. Okay. So remember, we missed one, the scikit-learn as a library. So we can just go back under our requirements.txt file. Before this, we can just add the scikit-learn library. It will be very important. So we'll just wait for this to complete executing or installing, then we can do the same process again to make sure we have the scikit-learn. Okay, so also we have the packaging project where you define which files and directories should be included in your package and all that. The distribution, the setup.py, you can distribute your project through the Python package this. So if you want to make your project as a module, then the setup.py is where you need to define that. Okay, in the requirements.txt, this one will specify the dependencies that will be required to run our code. As you saw earlier, we created those the dependencies are the libraries. If we are going to use the layman language, so those are the libraries, the modules that you will be needing in your project. So we created the requirements.txt file, place them there. Then using the setup, you can just call those libraries and install them. And in the requirements.txt file, we included the -e dot or -e dot. So the -e dot entity is a specific notation used in Python packaging to specify that the current directory should be installed as an editable package. That means if you're going to make changes in the package, we don't need to reinstall everything again. We just it immediately takes effect without needing to reinstall the package itself. So for example, you can see that we missed adding the scikit-learn library. Okay, so when we do this again, when we reinstall or do the pip install, it won't need us to again install this afresh. Okay, don't need this process of installing the other things afresh. We just install the scikit-learn because that is the new addition or the new modification that we have made from there. Also, we do have the src folder. This is the source folder. It's used to store the source code of the project itself. Okay, the entire project development will be happening in this file. So this is the shareable file that someone else, you can give it to someone else to continue to make changes, do debugging and all that. So all our folder will be containing the src folder, and in that folder where you can do you can share that folder and all that. Okay, remember we use the init.py file in that folder to ensure that that folder is treated as a package. Under the components folder in the src, as we know in machine learning, we do have different modules. For example, we have the data ingestion module, or the component, data transformation component, model training. So as you can see, these components will be housed under the src folder under the component folder in the src. Okay, so you can see the data ingestion for ingesting data transformation, doing the pre-processing tasks, or the trainer to train our model. So the pipeline, basically a pipeline is needed because when executing our code, or when executing the different components, so basically a pipeline joins one component to another, and it defines which steps needs to be executed first and last. So that's the pipeline. So you need to have these pipelines, because even when we are doing a model registry and all that, it will be necessary that the pipelines should be it is necessary so such that we are able to define which steps to be run first, or which process should be executed the last one. So we can have the training pipeline, the prediction pipeline, model validation pipeline, and all those will be contained under the pipeline folder. We can also have the logger that will set the logging record or information and messages for that, and the exception.py we can customize handling our errors, because the entire code, we don't expect to write a code from start to end without errors. So we need to define ways that we can call those errors and see which how we can do the code, how we can solve those errors. So that will be under the exception.py. With the exception.py, we do have the config box, where you can think by that is already predefined how you can those errors will be raised. With the exception.py, this one you can create your custom exception.py, and you as the programmer, you can define how those errors will be raised. You also have the utils.py, the utility function. So these are the common tasks will be contained under the utils.py, so that we don't need to redo those processes over and over again. You can just call them from that file, then use them whenever they are needed. Okay, and we don't need to create them once we need them. Okay, so this is just a simple explanation of the different files that we need. Okay, so of course I didn't include the YAML, the params, the schema, but you'll just see how we will be applying those different files in our project. Okay, I think by now our project will have been done. So you can see error pip dependency, below this one, solver front foot. Okay, so we can see other dependencies were not installed. Okay, but I successfully installed this by passing maybe matplotlib requires this. Okay, so we did not include the matplotlib, so we can just the scikit-learn. We can also include the matplotlib as a library, the scikit-learn as a library. Any other are we missing? Let's include those. So let's do the pip install. So don't want to clear this, so just do the pip install -r. Make sure that when you have introduced a new libraries, you save that file. So pip install -r requirements.txt file. So requirements.txt. So pip install -r requirements.txt. So with the e-dots, you will see that we don't necessarily need to install this other libraries afresh. So it will just, you will see it will be telling us that these files you can see now the requirements already satisfied, numpy requirements already satisfied. So it won't need to reinstall these files again. You can see these requirements are already satisfied, so you won't need to install those until when it will be reaching to the module that is not installed. Then from there it starts the installation process. So as you can see, collection, this one is for the scikit-learn. You can see we are also for the matplotlib. You can see IPY kernel satisfied. You can see these are the things that were not installed under the matplotlib. So installing this, attempting to uninstall, successfully installed, running the setup, or develop your electricity bill project, found existing installation, and installing, then doing an okay. So I think you can now see how the -e dot in operation, this one, and why we leave it. It helps us in this, because imagine working in a project that you have 20, 25, even 50 or many dependencies. So you see, without having the e-dot, then every time you make a change in the dependency, you need to reinstall all those modules afresh. Okay, and that will be time consuming. So it's very easy to just use this e-dot annotation to help you with that. So let's complete this, and then we can do a git push to our repository. It might take some time. Just give it necessary time for that. So after this, what next? I think we can just do the logger parts. So we can just add the logger. We can just add the logger, and maybe call it a day. Then in the next section, we can start with now doing the necessary, the coding itself. Okay. So while this is running, let's we just give it some time for it to run. But let's go to our source folder. So in the SRC, we have the electricity bill. So under the electricity bill, this is where most of these components or necessary files are located. So there are two ways that you can use create the logger. So you can create the logger in terms of as a file itself, then import, or you can use the init method. In most of the cases, I think using writing your the login or the logger code in the init.py makes your work simpler. Okay, so you can either write it under the logger.py file or the init So for my case, or for this project, I'm going to use the init. Okay, so we say that the init underscore init makes the file as a package. So that means the logo will be recognized as a package, something like that. You can see successfully installed this one. I think that is done. So with the src, let's push this. So git add. So let's add those. So git status. So with the git status, we are able to see which folders we made changes in our setup.py and the requirements.txt. So we can say this one, we can say git commit -m. For the message, you can say project setup. Then after that, you can just from here we can just do the git push -u origin main. That's it. Git push -u origin main. So when you execute this, I think it's okay. Now it's okay. So let's work on the logging. So I'm going to import the necessary libraries. So I'll start to import logging. Import logging. Import OS. Also import sys. And from date time, import date time. We are going to define the log file name using say create or define. Let's use define. Using the current date and time. So for this case, say log file name. The log file is how we do it. So let us quickly brackets. So this time dot now name dot now dot strf time. Then we specify the format. So then we have the month, then we have the day, supposed to be month, and this is supposed to be the month, day, then we have hour, then we have minute. I think we're missing the year component. So our month, we'll do second. So here we can say here ms mh mdy. Okay, that's okay. Log, then create the path. The log file. So log file path. So log file path os.path dot join s dot get so the file path will be called logs. No, the file itself will be called logs. Log file name. Okay, then we create the logs directory. If it doesn't exist, so here you can say make directory os.path directory name, dir name log file path exist underscore okay 2. Then we do some configuration of the logger. We can say logger configuration. So logging dot basic config. Here you can specify the format. So for the format is sending time, I think. Sending time. And have the line number. Then we can have the name. Then we can also have the level name. And we can also have the message itself. So basically this is the log format. This is the log format. The level itself. So level logging info. That means only set up the only the info level messages will be erased. So this one is supposed to be logging.info. Also include some handlers. So file path. So this one will output logs to the file itself, the file that we have created up there. And we also need, you can also ensure, or you can also have login information under the terminal itself. So that is the Steam handler. Sys dot std out standard out. Output logs in the also output logs in the terminal or console. So we can have both. We can have both in the log file as well as the terminal itself. Okay, so end this by logger login get logger electricity bill. Okay, so let's try to import our logger using the main.py and execute it. So we can say from src dot electricity bill import login. Then we can say login dot info main folder. It's a simple message. Okay. Say ML project, main project folder. So let's see if execute this and see if it will be working. So from src you can say python main.py. Getting an error. Supposed to be get log. So you can see we are having a we have created the logs file. So there was an error under the logging. So let's review it. Supposed to be logger like that. So let's run this again. Python main.py. So you can see that so for our logger is now working okay, and you can see we have two messages. Let's do this. So Python main.py. You can see we do have two. We have the logs file, this one here, and we also have in our terminal. We also have the logs file. So you can see we have the this is the year, this is the time. Okay, and this is the level name. I think is 3. This one line number is 3. Sorry. Then the info message. We only say the info message will be erased. Okay, and in our logger again, you can see we are getting the same message again. So our logger is working okay. So that means the reason as why we are using the init underscore the init.py file. You can see we are now importing. If you search, I don't think there is any module like this. There's no module named, let's say, from the Python library and all that. You cannot find a module like this. So, but because we have the init, the underscore init file, so it considers the whole of this as a package so that we can import that and use that in different sections of our code. So you can see we imported this from SRC, the source code. Under that we have the electricity bill. So the electricity bill import logging, and we wrote a message like this. You can see we are getting an output from that. So that's okay. So I'm just going to delete this. It's not necessary. The logs, that's not a problem. Then we can just save this and close requirements, the setup. So after this, we can just again push this code to our GitHub repository. So we can say git add dot, and then we can say git commit -m. We can say logger. That's okay. So logger, then git push -u origin to main. Okay. So that's it. And then when you go back to our file, you can refresh this. So remember, we worked earlier on, we worked on the setup.py. So the setup.py, you can see this is the code for the setup.py. You can see for the requirements.txt file, you can see that these are the requirements that we needed. And in the logger file, under the init.py, it's supposed to be the electricity bill. The electricity bill does have an init, this one. So you can see that this is our code itself. So that's it for today. Once again, I'm very thankful for your time. And before we call it a day for today, again, please, requesting for your assistance. Please do subscribe to this YouTube channel, and please set up the notification bell so that whenever we have any content we are trying to push out, we are trying to upload, or sometimes we might go for a live session. So you will be getting notification for that, so that you never miss any of our videos. Once again, thank you for your time. Let's meet during the next session, where maybe we can try, for example, we can do the setup, start with maybe the components and all that. So okay, so that's it. So that's it for today, and until next time, see you. So hello everyone, and welcome back. So today we are going to continue with our MLOps project. So starting from today, we are going to start we're going to start with the building of the model itself. So yesterday was all about project structure, the files, necessary files that we need, and all that. So we did that yesterday, and it was successful. So today we are going to embark on a new chapter under our entire end-to-end machine learning project. And in today's session, we are going to start with the modeling part, then introduce other concepts like the purpose of the utils code and any other constants. So we deal with the constants in we deal with the constants in the code. Then we start the other procedures as well. Okay. So as I said, you're going to start with the modeling part. So this is the modeling part. So I had done this earlier. I did this in a Jupyter notebook separately from this. Then after that, I just downloaded that Jupyter notebook. And then as you can see, it's just an IPYNB file. You can see it's an IPYNB file. So after downloading that, I just went to the research folder in my local machine. under this where we are doing this, where we are building this model. Then from there, just under the research folder, I just saved that file. Then I can access that through the VS Code. So this is the file itself, the electricity bill prediction. So this is where I did the modeling part. So in terms of the modeling part, I assume that up to now, you given any data, you're able to try to build a model for that. Okay. So as usual, we can start by that. So we start importing the libraries, then you import the data set. All this, I think by now you have some understanding as to why we are trying to use these things. Okay. So just to go a little bit faster, so we import our libraries, the pandas, numpy, matplotlib, seaborn. Then we import our data set. Then you can use the info method to get some information about your data set. For this case, I used the info method to get information about the number of columns. So you can see we have a total of columns, total of 12 columns. Sorry. Then we can see we are not missing any values. Then we can also get the data types of the values under those columns or the attributes. Then from that, I try to rename the columns, but this is not important. Then you can convert this into a CSV. So for example, let's say you are dealing with the data like this, and then after doing some data cleaning and all that, so if you want to convert your data into a CSV, then you can just use this this code here. But for this case, I'm not using that. As you can see in our data, we do have our data has different types of data types. We have the integer, the floating point number, as well as the objects. Objects are usually a string of string type. Okay. So I use this for loop to try to loop through each column and print out the count of the categorical values under those columns. We have two columns that are having categorical values. So I use this for loop. As you can see, we have a city, and this is the count or the frequency of that city in our dataset. Then we also have the company name. This is just it's not showing because this is truncated. Open text editor. Okay, yeah. So with the text editor, you can now see the different companies. So the column is the company, and the categorical values count for those. So we have the different companies and the count of, or in other words, the frequency for that. So after that, because we do have categorical values, and I then moved to the next step, which is about, I'll call this a data preprocessing step. And I use the one-hot encoding to try to encode, or encoding is just another way of saying I try to substitute the categorical values with numeric values, because the algorithms that we are using do not accept a string as an input. So I use the one-hot encoder. So the one-hot encoder is slightly different from the label encoding. So with the one-hot encoder, so I just created a list of the columns I'm going to encode. Then created a copy of the data frame. Then from there, we just did the one-hot encoding. And then after that, when we print out our results, you can see this is the output. And as you can see, the output is in a form of sparse matrix, which is expected because we are using a one-hot encoder. It creates a dense sparse matrix for after the one-hot encoding. So if you want to check the documentation of the one-hot encoder, you can just say one-hot encoding from sklearn. So from here, from sklearn one-hot encoding, from there you can see the documentation for that. So the preprocessing step using the one-hot encoder. So from here, you can, if you take time to read through, you can see how we apply the one-hot encoder. Okay, so encode categorical features as a one-hot numeric array. The input to this transformer should be an array like of integers or strings, denoting the values taken. So you can just read through and see how the one-hot encoder operates. Then after that, since now we have successfully we don't have strings as our input, then the next step is all about now building the model itself. So I didn't want to just use one algorithm, but I wanted to use several, so that I can select the best. Okay, so I listed some of the algorithms that I used, so including the decision tree, the LGBM, SVR, cut boost, XGBoost, regressor. You can decide to use whatever you feel can be the best. So out of this, then I can select the best. So moving forward, then we define the features and the target variable. Features and the target variable. Then I dropped the null values in those. Then after that, I moved on to the training set and the testing set split. Then from there, I did the scaling using the standard scaler. Then I started with the modeling part. So you can see how XGB regressor, you can see how the cut boost regressor performed, random forest, decision tree, and LGBM regressor. So out of this, I chose to work with the decision tree regressor. Actually, in terms of when doing the evaluation, the random forest performed better than the other algorithms, but the only concern I had with the random forest was that it was quite slow in terms of training and doing the prediction. So for that reason, I decided it might offer a challenge when we start when we build the model with the random forest regressor. So for that case, I decided to go with the decision tree, which performed quite better compared to the other regressors. For example, and in terms of evaluation, my main concern was the mean absolute error as well as the root mean squared error. So when you look at those two evaluation metrics and compare with the rest, you can see that the decision tree actually worked better than the rest. So that's how I selected that, and from here we are going to build this project, the electricity bill prediction, using the decision tree regressor. So you can use the same, or maybe get this, do some minor changes here and there and see which one works best for you. Then from there you can build a model with that. Everything will tend to remain the same, but we'll just change the algorithm that we are using in case you want to use a different one. Okay? So that was all about the modeling part. Then after that, then I just push this code to the GitHub repository. So yeah, so I pushed, but anyway, I deleted the terminal. Anyway, so after that, you can just push this if you are following through. So that was all about the modeling part and the data that I used. I'll make sure to link the data that I used in the description section so that you can also practice with it. So that was all about the modeling. So the next segment that I'm going to tackle is about the common things in this model. And one of them is about the utils. So in terms of the utils just represent the functions and classes that are designed to perform the common and repetitive tasks. For example, loading, For example, when we want to save an object, when we want to load a file, things like those. So that is the function of utils. So I had explained I think in the previous video the utils and how we are going to be using that. So for example, under this section, these are the necessary inputs. And when you look at these inputs and what we imported yesterday, for example, remember, this is the box exception. We have the YAML, we have the JSON file, we have the config box and all this. So when we want to read a YAML file, then we'll just be calling this function, the read YAML, and then it will help us to read any YAML file that we will want to access in our model. So for that case, that's why we yesterday we imported the PyYAML. So that library, it will enable us to access or read data from the YAML file. Then we also have the create the directories. Of course, every step of when building this model, there is an artifact that might be formed after every step. For example, when we are doing the data ingestion, or for example, when we are doing the data transformation, we might get the preprocessed training set data. So that's an artifact. So we need to create directories, different directories for those artifacts, so that they're not just compiled in one directory, so that if someone is following through, can able to define the different artifacts and will be able to note where they are coming from. So for that reason, we are going to use this function to create the different directories. Then in terms of joblib, I'll be using the joblib the joblib format for the model. So you can also use the pickle, so to pickle the model, but for my case, I'm using joblib. So to save any joblib file or any joblib as an artifact, then we can use the save object to load the same. When you want to access that and load that into your code, you can use the load object function. When dealing with the JSON, again, you can save the JSON file and load the JSON file. So these are the utility functions that will be common or in our code. So to handle those common tasks, we just create a file for that, and then we can import this as a module or as a package in whatever in whatever place we will require it. Okay, so that's why we have the commons. We have the utility functions. Okay, so after this, and then the next step is about the constants. So under the constants, we do have the config file, the params, and the schema. So for the config, this one will when we start building the model, you will understand why we are using the config. And for the schema part and the params is about the parameters, the hyperparameters of the model that you will be using. So if you want to, for example, do the hyperparameter tuning, or if you want to change the values of the different hyperparameters, so we'll use this params.yaml file to specify the different hyperparameters and also specify the values for those hyperparameters. Okay. So when for the schema, it's all about when we will be doing the data validation. So for data validation, when I go back to my electricity, this file, so when you go back to where we were building the model, you can see that, let's wait for it. you can see that we do have the different columns as well as the data type. So under data validation, we will be doing a validation, and this validation will be for making sure that our data contains the necessary columns. So we have 11 columns. So we have to make sure that our data contains these columns and contains the specified data type. So that will be all about the data validation. And for data validation, then we'll be using the schema. So we'll copy the column name and assign them the data type, so that when we do the data validation, it has to bring, or it has to print the column itself as well as the data type for the values under in those columns. If there is a mismatch, then it raises an error. Then you have to correct that error. For the config, it's all about I think it will be all about the different paths. So for example, if you want to set the path for the training data, then you can do that in the config.yaml file. Okay, so that's for that. So all those, you can see again, those three things fall under the constants. That's why we do have the constants file here. You can see we have the YAML file, the config.yaml for different paths, params for the hyperparameters and their values. Schema is for the data validation. Okay, so you can also add other types if they are necessary. Maybe in terms of if you have to save the other forms of metadata for your model, then you can just include them under this section. Then prepare the YAML file from here, and you will see how we call these types of files. You can also use the JSON, but I think the YAML file is better than the JSON file in terms of reading the data in those files. So that is all about the commons. So you can see the commons, and also the constants. So that part was all about the common or the repetitive tasks in our model. Okay, so we can again just push this to GitHub, and then from here I think we are going to start with the data ingestion. So just open a new terminal. Git commit. Then for the git commit, you can just say commons. That's okay. So we are going to start now with the process. We are going to start with the data ingestion. So I'm going to start for the data ingestion. We are going to start by, so under the research folder, I'm going to create a new folder, and for this folder I'll say let's say part 1 data ingestion. So we're going to start with the data ingestion. Under the data ingestion, as you know, with the data ingestion, we are trying to load data into our system. So you can load data from different sources. You can load data from different sources, from either database, from your local machine. So there are different sources, places where you can load data from. For my case, when you go to my GitHub, I have a folder, or let's say I have a repository, and inside this repository I have my data. Let me just show you. So for this data, I have this repository, and in this repository I have my data. I think this is the data electricity bill read. So it's data in a zipped file. So I'm going to read data from this section. So this is my source where I will be obtaining this data. So let's start by importing the necessary libraries. So import the necessary libraries. So we are going to start by from data classes. So remember, here we'll be using classes. We'll be creating classes, objects, and all that. So from data class, so data classes, import data class. Then from pathlib, import path. Then also we need to import the necessary then we're going to again import necessary let's say import specific constants and utility functions. So for this case, for example, we have the constants, this one. So we need to import this. So I'm going to import this. So from src from src dot electricity bill dot constants. We're going to import. So here, for the constants, we are going to import everything. So what we can just do, we can just use this one. So it will import the config, it will import the config file path, params file path, as well as the schema file path. So at the moment, remember these files don't have data. So that we are not going to create, bring or print or raise an error. You can just in the meantime provide a value for that. So key and value. Then for the params, you can say key and value. So that's it. The config again, you can just save this. The params again, you can just save this. And for the config, you just say key and val, so that they won't result in an error. So you're going to import those, or if you want, you can say config file path. You can also say params file path. You can also say schema file path. Okay, that's it. Or you can just use the one I used earlier. Then from here we can also say from src.electricity bill. Then here we are going to the utils. So in the utils, we are going to commons. We are going to import the read YAML file, because all these are in the YAML. We are getting access to the YAML file, so we need to read the YAML file. Then we can also create the different directories. Okay. Also, we need to import other libraries. For example, we need to, let's say, import OS. Also import, because we will be downloading, we'll be importing this data from a URL. We'll need the URL. So URL from URL lib dot request as request. Then we also need the zip file. So import zip file. Then we will also need the logging part. So we also need logging from src electricity bill import logging. And from here again, you can say, you can also import from src.electricity bill. You can also utils utils. No, you can just add that one here. I wanted to use the get size function, so that we can get the size of the files itself. Okay. So after you are done with this, we can now start defining the different classes. So we are going to define the structure. So here we are going to define the structure of data ingestion configuration. So data class, data config. So data class. So you can say class data ingestion, data ingestion config. Under the data ingestion config, so basically we are going to define the path to the data ingestion configuration. So when we are going to define this path, as I said earlier, we need to now go to our config the .yaml file. So under this, we are going to state the different file paths, the file paths that we require. But before we set that, we need to create the root directory. So artifacts root directory. So this is the artifacts, that's the root directory. So artifacts, root artifacts. So all these artifacts will be contained under the artifacts directory. Okay. So we need to define the different file paths for that. So for the data ingestion, we need to define those paths. So we need to define the root directory. So, the root directory, it will be artifacts the data ingestion. Then we need to specify the source. So the source of the data. So source URL. Source URL. So you can just come to our here, then you can just click view row, then copy link address. Use the copy link address, save link, copy. Yeah, you can just copy this link address, then paste it here. So GitHub, mini code, data hub, row, mini main electricity bill. Okay, so that's okay. Then you can set the local the file path now. Local data file, so that is artifacts, and data ingestion data.zip. Then we can unzip. So this one from the URL, it will come as a zipped file. Then we need to unzip this. So unzip directory. This one will be artifacts stroke data ingestion. Artifacts slash data ingestion. Artifacts data ingestion data zip. Artifacts data ingestion data zip. Then artifacts data ingestion. Yeah. So this is the root directory, data ingestion. It will go under this data ingestion. We're going to access our data. We're going to download data from this link, and after we have downloaded that, it will be saved as a zipped file, and then we need to unzip that file. Then after unzipping that, we are going to save now our data into in the data ingestion artifacts data ingestion folder, okay, as an unzipped file. Okay, so we're going to save that. So we can just in the meantime delete this. So then go back to our data ingestion. So whatever we did under the config file, these things, this is what you're going to place under the data ingestion config. So you can just copy this, and then under the define the paths. So the paths, then you can just do away with this and say this is the path for that. For the source URL, we can call this as a string. We can refer that as a string. Then this one can be path. This one is the path, and the artifacts also. This one is a path. This is a path. So this is a path. So that's okay. So after creating the data ingestion config, so in other words, we'll consider this as our entity. This is our entity. So after creating that, we are going to create a configuration manager class. So we are going to create a configuration manager class. And this is to manage the configuration, manage the different configurations. So under this, we can say class configuration manager class configuration manager def init, so that's okay, self, and then what we can do for this section, so whatever details we used up here, we are just going to repeat the same. So for the self, we are going to self, then the config file path, config file path, params file path, schema file path. Okay, that's okay. Then after this, we need to initialize configuration manager. So initialize the configuration manager, then self.config file path. Okay, but remember we are dealing with the YAML. So this is where we call the YAML, the function. So read YAML. So to initialize this one, so be self dot config. So the read, let's go the YAML. I think this one is it, if I'm not wrong. So the read YAML config file path, self.params read YAML params file path, that's okay. Schema read YAML schema file path, that's okay. Then we, after that, we need to create a root directory. So create a root directory. So create the directory. So it will be self.config dot artifacts underscore root. So this, we use this to create the root directory. Directory self.config artifacts root. So that's okay. So we can do away with this. Do we need this? I don't think so. So initialize the okay, so that's okay. Then after that, the next step is all about create and return the data ingestion config object. We're going to create and return the data ingestion config object. Config object. So we can say data ingestion config. So just do away with this. Data ingestion config, data ingestion config. Then the root directory. So it will be config. We don't need to specify this. Just do away. Even this is just okay. So config dot root root supposed to be root directory. Config dot root directory. Source URLs. Config the supposed to be config dot source URL. Then this one should be config dot data file. Then the unzipped file should be just like this. So you can just do away with this. There is something we are missing. We are missing data ingestion config creates. After we have created the root directory, and then like I'm jumping way ahead. We need to define or get the data ingestion config first. So get data ingestion config an object. So self data ingestion config. That's okay. Then after this, we get the data ingestion configuration. That's now okay. So config.self, config.data underscore ingestion. Then after that, we can create a directory for that. So create we create data ingestion config object. So create the data ingestion config object. This one will be create directories. Create directories again. Root directory. Okay. Config the self data ingestion. Create the data ingestion config object. Then data ingestion config. Root directory. Is something I'm missing, huh? Read YAML configuration files to initialize. So that's okay. And after that, create necessary directories specified in the configuration. So here we can just create necessary directories specified in the configuration. Create directories. Self.config artifact root. That's okay. Then okay. I think it's an indentation issue. Supposed to be aligned with this. So so if data ingestion config self data ingestion config, that's okay. Then we get the data ingestion configuration config self.config data ingestion. That's okay. Then we create directories for that. Then this one should be this. So data ingestion config. Then after this, we need to return something. Going to return data ingestion config. So if you want to do an explanation of this, remember I'm using tab 9, and if you want to explain, you can just click the explain sort of button. Then you'll get a full explanation. So for example, so we are selecting the class configuration manager. The selected code snippet with the configuration manager class is responsible for initializing the configuration manager and loading the configuration parameters from the different YAML files. As you can see, we are passing in the different YAML files, and these YAML files contain data information. So the configuration manager will be responsible for loading the configuration files parameters from the YAML file. So it is responsible for reading data from the YAML files. So when you can see, the init method is a constructor for the configuration manager class. It takes 3 parameters, that is the config file path, for the config file path, for the parameters file path, as well as the schema file path. And these parameters represent the path for the YAML file that contain the configuration parameters and the schema respectively. So those are the things that will be stored under those files. So inside the init method, the read YAML function is used to read the YAML files. So remember, we created the read YAML file function in the utils. So we are taking that function from the utils and pasting that function to the configuration manager, so that it enables us to read data from these file paths. Okay. Then after loading the configuration parameters, the create directory function is called with a list containing the artifact root directory from the config attributes. Remember, we created that function. This function creates the specified directories if they do not already exist. Okay, so we are going to create directories if they don't exist using this. Now, for the configuration manager, you can see that it's just responsible for initializing the configuration manager and loading the configuration parameters. This is quite different from now now after that you're going to get the get data ingestion config, and the selected code is a method within the configuration manager class. This method get data ingestion config is responsible for retrieving the configuration data ingestion settings to the project. So if you need some documentation for that, then you can get it via tab 9. So it's able to explain to you the different things that I'm doing with this. So for example, get data ingestion config self. So with this one, this method retrieves the data ingestion configuration from the YAML files and creates a data ingestion config object. So the parameters for this are the configuration manager, what we are getting up from the configuration manager, and it returns the data ingestion config, an object that contains the data ingestion configuration, and then it will be raising an exception. So with the config, we are getting the data ingestion configuration from the YAML file. Then after that, we are going to create the necessary directories for that. Then create and return the data ingestion config object from this one here. Okay. Then we are returning the data ingestion config. Okay. So if you can just tab 9 is an extension. So you can just install similar to something like Git Copilot, something like that. So you can just install the tab 9. You can install the tab 9. This one here, you can see I'm using the tab 9. AI autocomplete charts for JavaScript, Python, all that. So it comes in handy. You're able to now explain your code. If you're stuck, it's able to assist you getting unstuck. Okay, so that's the data ingestion config. So after this, we are going to start defining the class, defining the data ingestion component class. So this class will be responsible for doing the manual work, getting to the URL, downloading the file, and doing all sorts of work. So we're going to create the class data ingestion, self config data ingestion config, then self config. Okay, so you don't need this one at the moment. It's just something about the logger. So after this, we are going to start then to create a method, download the file from the specified URL to download a file from this specified URL. So remember, we are downloading our data from GitHub. I showed you that. So we're going to define that. So define download the file. So we can just use self. So self, and then I'll create my own custom function. So remember, you need to indentation should be correct. So I'm going to use this. So if not os.path exist, then you're going to create self dot config dot local data file. So if this path does not exist, then you need to create this file first. Okay, and Also, if the file does not exist, then we need to locally download it. So file name headers, we're going to use the request URL retrieve, and URL retrieve, then say URL config source URL, that's okay. Then file name, for the file name self.config local data file, so that's okay. Then from here we can then pass so if not as os.path exists self.config file, then if the file does not exist locally, download it. File name headers request that URL retrieve URL, that's file path. Then from here we can set up some login information. So login.info, we are downloading this file. And say downloaded. The file this file name with the following info. This information is in terms of the headers, so the header names. So headers, that's okay. Then we create the else block. So else else the else block we can say so now if the file exists, get the file size. File size, get size, self-config local data file, login info of the file. This already exists with the size this bytes. So that's not so that's it. Then we need to create another method to a method to extract the zip file. If extract zip file, so need to check if the zip file exists. If not os.path exists self.config and zip directory. If the zip file does not exist, unzip it with zip file self.config local, that's okay. and then logging info f extracted the zip file, f self.login this file path to this, then else if the zip file exists, get the file size again. Okay, no problem. So we we are downloading the file, then extracting so that we get the zipped file. So that's not a problem. Then after this, that's all about data ingestion. So we can say, can create the main pipeline. So in our main pipeline, you can say if underscore name underscore so main underscore that. Then you can use a try block so that in case we have an error, we are able to trace that. So exception as E, then you can just raise E. So for the pass, we are going to change this. So we start. Need to initialize configuration manager. Get the configuration setting to get the configuration settings. So this one you can say config manager. Let's just use config. Configuration manager, that's okay. Then from there we need to do data ingestion configuration. So data ingestion config data ingestion configuration. So this one you can just say get the data ingestion configuration, that's okay. After the data ingestion configuration, and then initialize the data ingestion component. So data ingestion okay, that's okay. So data ingestion then you can just use the config data ingestion config. Then we download the file, data ingestion.download the file. So we are using the method we created earlier, this one. We're using this to download the file. And after we have downloaded the file, we need to extract the file. So we are using the extract file method that we created earlier. Then we can log some message. Logging. So for the logging.info, we can say that data ingestion completed. Data ingestion completed. Okay, we can save this. So you can see with this code, we are now running the data ingestion part of the config of the file. So we started by creating an entity data ingestion config. The data ingestion config as a data class, we are using this and specifying the necessary file paths. Then after that, we created the configuration manager, and as we saw we are able to use the configuration manager to initialize the configuration manager and loading the configuration parameters from the different file paths. Under this, we do have the get data ingestion config, the data configuration, the class, the method data ingestion config that is responsible for retrieving the configuration data. Now the data itself, retrieving the data. Then we created a new class that is going to perform the specific tasks of data ingestion. So the first one, we created a method to download the file. So it's a zipped file. We are downloading that from a specified URL. Then after we download that, we are going to extract that file. And then after that, we are creating the pipeline for that. So pipeline generally is just going to inform what should be executed first and last. So when running this code, it will start executing from here, and it will be reading the different steps and then going back and retrieving the necessary information. So I'm going to execute this file. I'm going to execute the data ingestion. So with the data ingestion, so let me just save this. Then we can run this file. So for this file, you can say, you can just open the terminal. And in the terminal, you can say Python. Then you can just copy the relative path that file. Then when we paste it here, so Python this and this. So let's execute it to see if when we execute this file, we expect to get, we're getting an error. Cannot import the name file of the error from SRC, this one. Cannot import the name file from SRC exception. So we are getting an exception.py. We do not create an exception.py file. Let's go to the commons, entity, exception, utils, entity, configuration, not entity, the utils, commons. I think this one, we are getting an error from this. This one, if we need to create something like custom exception, then we can use this. But I did not create a custom exception. That's why we are getting that error. Let's see if we're going to. So when you execute this code, we are going to get an artifact folder, and this artifact folder will contain the code itself. So let me see. We try to expand this. So you can see we are creating the artifacts folder. This artifact folder is under the data ingestion config. We are getting the data ingestion config. Okay, so this is the zipped file. So as you can see, under the logs, so this information, you can also find it under the logs file, but I'll show you that. But from the terminal itself, you can see that oops, we are getting an error. Zip file. So you can see, let's go to our logs. So under our logs, you can see that we read the YAML file. So YAML file config loaded successfully. The YAML file params loaded successfully. Created the directory at the artifacts as we specified. Created directory at the artifacts, data ingestion. Downloaded the file artifacts, data ingestion, like this. So this is just some metadata about that process. Okay, but I think we are getting an error. So let me see. Test back line 111. Let's see. 111 race E. So file is in module. Extract file gets unzipped file race argument path for the type class string to function does not match annotation type class path. So let's see what we are getting. I don't know why you are getting this, but let me. So this one is saying so you're getting an error from get size self config and zip directory. Get size self.config and zip directory. So this error is coming from this section here. So let me try something. So let's see. We're getting this error. Trace. Line 91. Let's see 1991. So extract file self. Check if there exist. If not, not os.path exists. Let's try something. So let's run this code again. We're still getting the same error. Getting the same error. So let's extract if not self exist. Again, extract as if file. But yeah, we're not getting the. We need to get. Need to get the. I think the CSV file itself. Let's try something else. So we need to create a directory if it does not exist. Create directories. Say unzip path. So self dot config dot unzip directory, zip directory, then os. Okay, so then let's just not use this. Let's say os dot make directory and zip path, then we exist. Okay, this one is true. Then we can extract the zip file. In extracting the zip file, we can say with zip file self.config local data file r as zipref. Then you can say zipref extract and zip file. Logging if extract the file. Okay, so let's see. Just do a CLS. Then you can save this. Control save. So you can say Python. Copy relative path. So this is the pain of handling errors. Oops, so we're getting another. Let's see. The load file if not os.path exists self.config local file data path. If the file exists, then we can do this logging. So logging.info f the file file size. So you can say get size so path self.config local data file. So let's see. Let's download. Can delete this. Then run the code again. Control C. Just paste it here. Make sure you save this. Then just wait. We're getting the same error again. Getting an error from accessing that file. Connection attempt failed because the connected party did not properly respond after the period of time, or established connection failed because connected host has failed to respond. Then I think it's not accessing the file from it's not accessing that file from the link itself. Config.yaml. This is the file path. Let's save this. Then new terminal. Say Python Let's see. This is a zipped file. Huh? You can just download the raw file and save it back again and see. But in the meantime, that's why you're getting some errors. Relative path. The problem is coming from that link not being able to access this file. So yep, the same thing. Yeah, it cannot access this file from the said path. Anyway, so I think um, I think I'll just stop here for the moment, and maybe try to solve this challenge, this problem that we are facing. Then from the next session we can continue from here. So this is a problem you are encountering. So let me try to work out the problem. So what I can do, I can instead of reading this file from that zipped file, we can read that file, a zipped file. Instead of GitHub, we can use I think let's try using, we can use Google's Google Drive. Let's try Google Drive. So let's try Google Drive. Google Drive. So let's see if you can download this zipped file. So we can download that from the Google Drive. Let's try to more downloads. Let's try to save this in the Google Drive. Uploading complete. file information. So let's try download, share. We can share this. We can copy the link. Let's see if the link will work. Okay, the link is working. It will download and extract. Let's see if so we go to the YAML file. Then let's try use that link from the Google Drive, and then we can use again. So Python, copy relative path, then we can just paste it here. Then let's see if it will work. Error for one unauthorized. So we are having a challenge with that again. So I will look further into this problem, because I didn't want to load this from the local machine, because that's a common way of doing things. I wanted to try something extra, but we are having a problem with that. So I will sort out the problem that we are encountering with this reading from this link. Then from there, we will try to solve this problem and see how we can solve it. So data like that. So let me try a last option. So with this data hub, I'll just executable data zip file. So let's see, commit change. Now we have tried to this one. Let's see if this can be our last resort. Copy the link. So just copy this link, and then I'll just try to paste it here. And then save this in data ingestion. Python, and I can just copy this, copy relative path, and we can just paste it here and see. Yeah. Now it is working. Now I think it's working. We have solved that. Oh, okay, now it's working. So I think it was an issue with that that link, but now we can see that it's working. So I think we have solved that challenge. Let's delete this again. Let's delete the logs. Delete the logs again. So we can then execute this. Let me just copy this. Control C. Now we can create a new. Clear the screen, then copy that and run this again. So I think there was an issue. There was an issue with that link itself. That's why we were getting some errors. Even you can see, I tried that with the Google. So we were trying to load that data from the Google Drive, but again we're still getting the same error. So I've tried to just change the name of. I downloaded the zipped file, changed the name, then I uploaded it back. Then from there you can see we are able to read that file. So you can see this is just the metadata from that. So yesterday we saw how we can set our logs. So we were able to set the logs so that we can run our logs. We can get the logs in the terminal, and we can also get the logs from the logs folder. The logs folder again, you can see the data. You can see how we are getting the data. Okay, so that's, I think that is okay. We are getting we have now loaded our data. So from the artifacts, you can see we have the data ingestion folder itself. We have the data zip, so the data that was downloaded as a zipped file, then the electricity bill as a CSV file. So I'm going to push this data to the GitHub repository. So new terminal, I'm going to say git add. Then we can say git commit. Git commit. So minus m. Git commit minus m. So we can say data. Data ingestion. So these errors are common, and if you are able to solve these errors, then you are on the right path. So data ingestion, then we can say git push minus u origin to main. Git push minus u origin main. So that was all about data ingestion. So we can quickly just do data validation. No. So after doing the data ingestion, we can convert this code to a modular code. So the research is it's all about experimenting to find that your code is running okay. So we have realized that our code is running okay. So we updated our config file here. So we have updated the config. The schema, maybe if we do the data validation, then we can update the schema. For the params, until we get to model, for the schema, until we get to data validation. For the params, until we get to a model trainer, that's when we'll update the params. So we need to update now. Remember, in our SRC folder, we did have the entity. So the entity, the configuration entity. So under configuration entity, so entity, configuration entity, under the config entity, we can copy, so data ingestion, we can copy this. So data classes and the path itself, the config entity. So config entity, data classes, import data class. Then we import the entity itself. So the entity is this one here. This is the entity. It's the configuration part of the code. So that's it. We're going to save this. So that's it. So this is for the data ingestion entity. So you can just label this data ingestion entity. So the data ingestion entity, data class, that's okay. So after entity, we move to the configuration manager. So for the configuration manager in the SRC config, so configuration, under the config, we have the configuration.py, this one here. So config.py, we are going to set to so we go commons, we don't need config, we don't need configuration entity. This one we are done with it. So for the config, the data ingestion. So for the config, we're just going to copy this. This is the configuration manager itself. So we are going to copy until the data ingestion config. We are going to copy these two methods, configuration manager, and until the get data ingestion config, up to here. We're going to copy this, then we're going to the configuration, then we paste it here. And remember, we need to import some paths, or some you can see the config file path and the rest. So we need this one, we need to import this. So we can put this here. Read YAML file. So we need to go to this one here. And, then we need to import the data ingestion config. So data ingestion config, you can say from, I think this one, from src entity configuration entity import data ingestion config. Any other? I don't think so. I don't think so. So after the config, we go to the components. So these are the components, data ingestion components. So this one, so component 1, data ingestion. Data ingestion config. So we need to import, I think, import the OS in the zip file. We need to import this OS url.zip file, zip file. We also import to import the logging from src.electricity bill. We're going to import the logging. Gets before. So first, let's import the data ingestion, the actual this one component up to this place. So copy this, then data ingestion config. So you need to import the get size. Get size is about get size is commons, from the commons. So you just do like this, import logging again from src. You just need the get size. So get size, so we need to import the data ingestion config. So again, from src path, also we need to import the path. We also need to import data path data ingestion config. Data ingestion config, that one is coming from the entity. So we can say from src.electricity bill dot entity dot configuration entity, going to import data ingestion config. The data ingestion config, we are solving for that. Let's see if we are getting some error. So we can also import the path, that's okay. Data ingestion config, get size, and the logging, zip file, request OS, that's okay. So that is the component part of it. So from the component, we can also go to the pipeline. So we need to update our pipeline again. So we are done with this, we are done with this, we are done with this. So we go to we are done with this, we go to our pipelines. So pipeline 1, first pipeline is the data ingestion pipeline. Maybe this we can rename data ingestion just say pipeline number 1, pip 1 data ingestion pip pipeline 1 data ingestion. So for the pipeline, let's go to the pipeline. So for the pipeline, data ingestion pipeline. So for the pipeline, this one the pipeline. Let's go to our code. So data ingestion.py. No, we need the setup data ingestion. So essentially, this is our pipeline. So under the pipeline, we need to create something. So we create a class, data ingestion pipeline. So data ingestion pipeline as our class. Then if in itself, then here we just pass. Then we define create a method main. So when we call this method, we'll be calling our pipeline, and essentially our pipeline is this thing here. This thing up to here. This is our pipeline. So this is our pipeline, and we need to import these components. So we need to from src dot electricity bill dot config config dot config configuration. We're going to import configuration manager, so this one here. Then from src electricity bill dot components dot c1 data ingestion, we're going to import data ingestion. So we are solving for this. Then we can import the logging. So from src dot electricity bill, we're going to import logging. That's okay. So you can call this surface. So just call it a pipeline. So you can name it data ingestion pipeline, data ingestion pipeline, data ingestion pipeline. Plus, then if you call this is this. So we need to add the if statement here. Let's go name underscore then underscore main underscore like this. Then you can do this. Then you can use the try block. Plus, then you can use the exception as e. Then you can raise e. So for the pass, you can do away with this. Then you can say login info so you can say and put something like this. Say pipeline name. Pipeline name. So here you can say pipeline name. And started. Then like this. And, pipeline data ingestion pipeline. Then pipeline main. That's okay. Pipeline dot main. That's okay. Then we can say logging info dash pipeline ended. That's pipeline ended. And say terminated successfully with some exclamation mark. Okay. And add something here. say n x something like this. Just use asterisks. Something like that. You can raise E. I think that's okay. So after running our pipeline, we can go to the main.py. So we created a folder main.py. So the main.py is where we can execute everything from. So we can from src.electricity bill import login, then from src.electricity bill pipelines pipeline number 1 data ingestion data ingestion pipeline. Okay, so this one you can say component _name data ingestion component, and say data ingestion component, data ingestion component. Then we can say let's try block element here. So exception except exception as E. So we do this, then say login dot exception E. Then we can raise E. For the pass, just go back to our data ingestion. Can log in this. Let's see for main.py, just paste this here. So login, try component name let's say component name data ingestion component, try logging info f component supposed to be component name. So we can just change this to component name. So started like this, data ingestion pipeline, data ingestion.main. You can say data ingestion pipeline, so login info data ingestion pipeline.main. Okay, so after this, let's Python. So we can again delete the artifacts folder. Then we can also delete the logs folder. Then we can say python main.py. Python main.py. When we execute this, python main.py. Okay, it's running okay. Yeah, now everything is okay. Now you can clap for yourself. Now everything is okay. We started by so after we have the data ingestion part. This is all about something like an experimentation. So we first did an experimentation to see if our data ingestion will work. Okay, so we imported the necessary libraries, created the necessary classes, and we came to find out that yeah, these things will be working okay. So after we are done with that, we need to make our code into a modular code. And we started by the entity. We updated our entity, then went to the configuration manager. After the configuration manager, we went to the components, then the pipeline. Then after that, we went to the main.py where we can execute our code. So with the main.py, we are only executing our code that is under the SRC folder, not the research folder. Research folder is all about experimentation, just to see if your code will be working okay. And we have seen that it's working okay. So after that, let me just push this code to the GitHub repository. So you can do the git add, then git commit. Commit, we can say data ingestion complete. Then git add, then git commit. So after git commit, git commit minus m, you can say data ingestion complete. So after we have completed our data ingestion, then we can say git push minus u origin main. Main. So I think that's it. Now we can push our code to the GitHub repo. So from there, you will be able to access it. Let's just give it some time. So we encountered an error. So then you saw how we can solve that error. GitHub failed to connect. Not contain to serve. I don't know why I'm having challenges with this. So let's do this again. So git add git status git commit minus m and say data ingestion complete. Git push minus u origin to main. Yeah, now it's okay. And let's see. Git push. Let's go back to our repository. Then electricity bills. So we have worked on data ingestion complete SRC. And the SRC electricity bill. Then we have worked on the components. We have worked on the data ingestion. So you can see this is the code for data ingestion. So I think it's okay. So you can do a git pull from here, work on it. In the next video, the data ingestion, I will try now to read data from the MongoDB server. So we can create a MongoDB server Atlas. Then from there, I think they have a free version. So if they do have that, we can upload data to the MongoDB server, then access that data from that server. So that will be in the next example. So stay tuned. So once again, I'm very grateful for your support. I'm very grateful for you watching. So please consider subscribing to this channel. We are welcoming you to this wonderful community. Hit that notification bell so that you never miss any of our video updates. So the next step after this will be about the data validation. So you'll see how we'll validate our schema, that is the columns and the data types. Then from there we can see the data transformation. The most complex part is about the data transformation. Data ingestion and the data transformation, those are the most, you can say, challenging part. Okay? So I think that's it. That's it for today. Until next time, see you. Bye-bye. Hello everyone, and welcome back. So we are going to be continuing with the series. In the last video, we did the data ingestion component. So we saw how we can read data from a particular source. So our source was data from a GitHub repo. So from there, we were able to ingest the data into a model. So up to now, our model is able to read data from a particular source. So you can watch the video, the previous video. So if you haven't, from there you will learn. You will learn how to ingest data into your model. There are various ways we can ingest data into a model. The most common ones I think will be ingesting data from, let's say, a database or a cloud database, something like that. So in the future videos, we might consider trying to ingest data from a particular source. For example, Amazon S3 buckets, or also we can also use the Amazon databases just to import data into a model. Another source of data can be, I think that's also a common one, Atlas. I think Atlas from MongoDB. You can also ingest data from that. So in the future videos, we might consider ingesting data from, so we'll be trying ingesting data from different databases or different sources. Okay, so at this point, before we continue, please consider subscribing to this YouTube channel. We are welcoming you to this wonderful community. You can also hit that notification bell so that you never miss any of our video updates. With all that said, let's get started with the data validation. So before we get started, there were some things that I tried to modify, and one of them was that I didn't want to commit the artifacts. So the artifacts, the data, as well as other artifacts. So I won't be committing them to my GitHub repository. So to do that, the first thing that I did was I started by, let me find it. Yeah, I used this git command to try to do away with the artifacts folder at the beginning. So as you can see, we are trying to remove these files from our GitHub repository. Then after that, we did a git commit to remove the folders from the repository. Okay, then as from GitHub repo, we removed this. Then we did a git push again. So when you go back to the GitHub repo, you cannot see the artifacts folder. So to ensure that the artifacts folder won't be committed, so when you can go to the git ignore file, and this is the artifacts folder. So you just artifacts, then the /. So this means that in any commits that you're going to be doing, henceforth, there's nothing from the artifacts folder that will be committed to the GitHub repository. So I'm trying to do this so that we try, most of the times, you might be working with the data in large quantities, and it won't be good enough, I think, to push the heavy files to GitHub repository. It won't even allow you to do that. So GitHub repo is only about the code itself. So you can also do the same, so that you won't need to push that those files to the GitHub repo. So that's what I wanted to inform you before we get started. So with all that said, let's go to the research folder again. And inside the research folder, we are going to create a new file. And this file, just name it part 2. And this part 2 is about data validation. So it's very important to validate your data, because to make sure you have the correct schema. So in terms of schema, I just want to emphasize that I'm talking about the columns as well as the data types for those values. So it's very important to make sure that you're dealing with the correct schema in your model, okay? So we are going to do that data validation. So as usual, we are going to start by importing the necessary libraries for that. So again, from data classes, import data class. Then we're also going to import the path. So from pathlib, we are going to import from pathlib, import path. Also from src electricity bill, we are going to import constants. So these are just the similar things that we did in the data ingestion. So I can just lift them from here. So I think this create directories, get size, and logging. Yeah, you can just copy this into a data validation. Okay, so that's fine. Then we can also import OS. We have imported logging. So import pandas as PD. So we are going to create our data ingestion config. So defining the structure of our data ingestion config. So we are going to define the structure of the data validation config using the data class. So data class, data validation config. That's okay, data validation config. So basically here you are going to define the paths, define the path for data validation config and all that. So as we saw earlier, whenever we are dealing with paths, we need to go to our config.yaml file, and inside this we need to specify the necessary paths that you're going to take. So here we are in the data validation. So data validation, then we're going to let's say the root directory. The root directory, that will be artifacts dash data validation. Then we are going to unzip. So unzip data directory. So unzip the data directory, so that will be artifacts, then data ingestion, then electricity bill datasets. So electricity bill dataset.csv, then status file, so that will be artifacts, be artifacts slash data artifacts data validation. Then we'll have a file, so status.txt. So this file, the status.txt, will contain the necessary information that will tell us if we are successful in doing the data validation. Okay, so root directory, unzip the data. So we are going to unzip this data from this path. Again, data electricity.csv, unzip data direct, supposed to be artifacts. So I'm just confirming if everything is okay. So we can save this, go back to our data validation. So the same paths or the same configuration, are just going to repeat the same here. So define the class, define the class like this. I'm just going to do away with this first. Then we can call the root directory. So the root directory, so that's the path. Then the status file, just str as a string, then unzip edit directory, that's also a path. Then all schema, that's a dictionary, dict, yeah, dict. So we need to update our schema. So go to the schema. Under the schema, we need, now we can just do away with this. Under the schema, let me open the, so our data, just a minute, schema. So our data, this is our data. So the df.info, we can get the columns as well as the data type. So I'm just going to copy this entire information and go to our schema and just paste it here, and then remove the unnecessary things. So for example, just remain with the column names. Then we can do away with this. So the easiest way is just Control F2, then we can do a one-time delete. Then we can replace that with this. Then for the null again, we can again just Control F2 delete. Control F2, just do Control F2 and delete. So you can say columns, make sure to include the semicolon, then this one You can do that. So once you save this, so this is the schema. Then you can also specify the target column. So target column is the electricity bill. So you can just again copy this. So target column you can just use a name, target column electricity bill, then you can just do away this. So we have our target column. Then here we have the column names, fan, refrigerator, all the way till Twitter. You can just save this. I think this one is okay. I think this one is okay. We have now updated our schema. So from here, we can just do away with this. So we have the entire columns. You can say columns. These are the columns. So data validation. So all schema, we have updated that. So we then create a configuration manager class to, then we create a configuration manager class to manage the configurations. The configurations, so that's okay. So class config manager. So these are just the same things that we did earlier. So config manager def underscore init self this and this, that's okay. Then from here we need to initialize the configuration manager. Basically we'll be reading the YAML files. So self.config read YAML file, config file path, YAML, the parameters, and also self.schema read the schema, so that's okay. Then create necessary directories, get the directories self.config, so that's okay. So I'm getting an error. Params file path, params, getting an error. This path is not defined. Config file path, params. directory status, that's okay. I think it was an indentation issue. I think it was an indentation issue. So we can just, yeah, indentation. So if we do like this, yeah, we think it was an indentation issue. Okay. Let me confirm something. Yeah, I think it was indentation. Don't need this. So initialize the configuration manager, read the YAML configuration files to initialize the configuration parameters, then create directories for that. Okay. I think prefer them to be aligned at this. They should be aligned like this. This is better. So after this, we get the validation config object. So when you reach at this point, then these are just the normal things that get the data validation config object, config self, config dot data validation, then schema. Need to add the schema. So schema self dot schema self dot schema columns. Okay, self dot schema dot columns. Then after this, we create the data validation configuration object. But before that, we need to create directories for this. So create directories. So config.root directory. Config.root directory, that's okay. Then after this, create data validation config object. So data validation config, data validation config, the root directory. So whatever we are passing in here is what we used in the data validation config. So just the same thing. Then after this, we need to return the data validation config, this one here. So as I showed you earlier, I'm using a tab 9. Then if you just need an explanation of this, you can just click explain, and tab 9 is just working like similar to Git collab. I think it's collab. So just the same thing. So under this, as you can see, the selected code within the configuration manager class is responsible for creating and returning a data validation config object. This object encapsulates the configuration parameters required for the data validation. So this code snippet demonstrates how the configuration manager class manages this and this and this. So you can just read through and try to get an understanding of what is happening here. So after that, then we need to create now the class that is actually conducting the data validation. So class data validation. So class data validation, def init, that's def init. So this one you can self config a data validation configuration, that's okay. and I can just do away with this. Dev init self config. Then self dot config. So that's it. Then we create another function method to validate all columns of the dataset against the specified schema. So if validates columns self, then we need to return something like a boolean. And just return a boolean value, either true or false. So inside here, I'm going to use a try block. So for the try, validation status none. Then okay, so data pd dot read underscore csv. So we are reading that from the unzipped directory. So config dot unzip data directory. Then columns. So you're going to list data dot. So the data, we're going to list the columns in the data. Then all schema and say self dot config dot all schema dot is and actually you can just use a for loop. So for calls in all columns, if column is in all schema, validation status to be false, then logging error column is not present in all schema. Can add something here. Let's see. So return validation status exception.e raise e. For columns in all columns, if column not in all schema, validation status false, login error. We are going to log in this. Else validation is true, login is present in all schema. Okay. So this is about validation or if we have all the columns. So we are going to create another method. So method to validate the data types of all columns. So def validates data types, that's okay. Try validation status none. Data, that's okay. All columns list, so just the same thing. All schema, so read the CSV file. Try validation status, that's okay. So here we read the CSV file. Then after reading that, we need to get all columns and their corresponding data types. Get all columns and their corresponding data types from the schema. So remember we prepared that schema. Then after that, we need to check if Then after this, we need to check if the data types of the columns in the dataset match those specified in the schema. Then simpler, we're just going to use something like a for loop. Else validation to schema. There's something we need to write this information to false, else true. There's something we're missing. If column not in all columns validation set as false, then we're going to log into error this. Then we need to write something. We have the txt file, so we need to write validation status to the status file, either true or false. So with open self config status file, save the config status files as fwrite fwrite validation status. Then we don't need this one again. Else validation true. Then again, if the validation is true, again we need to write I think that's okay. Then we return the validation status exception as raise e. So that's it. So for this again, need to get validation data types. So again, we need to write again we need to write that with open validation status. Then we need to return the validation status. So validation status exception as e raise e. I think we are having another indentation again. These challenges of indentation again, we need to do like this. So we are in the same indentation def okay whether to validate. Then else validation is true, okay, validation as e. Then after we are done with this, we go to our main pipeline. So the pipeline, if name sign, then main, oops, underscore main underscore. Then we can say try block, just say pass at the start. Then we can say accept exception as E. Then we can say accept exception as E. Then here we can just raise E. So we start defining our pipeline. So the first one is about initialize. You're going to first initialize configuration manager. Initialize the configuration manager to get the config settings. Accept. Okay, so and say and this is just your config. And just use configuration manager, data validation config. Then you can just use config, get data validation config. So we initialize the configuration manager to get the configuration settings. Then after that, we get the data validation configuration, data validation config, data validation configuration, this one here. Then after we are done with that, the next step is about the data validation. So data validation config. Then we validate the columns of the data set against the specified schema. Validate the columns. Then we validate the data types of the columns again with the specified schema. Then after that, we can use a logging message to tell us that the data validation was complete. Then if you have an error, we can raise the exception here. So I'm going to save this. Hopefully everything is okay. So I'm going to execute this file. So I'm going to execute this. So control save. So let me terminal, new terminal. Then I'm going to execute this. So with this, I'm going to say Python. Then data validation, you can just copy the relative path. Then when you paste at the terminal, then press enter. So with this, we are going to get another folder under artifacts, and it will tell us either true or false if we have the correct schema. Okay, so if we are going to get the correct schema, I think we are going to get a yes. I think data type column auto pump the schema matches the schema, data validation complete. So now, as you can see, everything is okay. So you can go to the data validation status.txt, you can see true. That means that we have successfully validated our data, and we have ensured that all the columns are existing, same as the data type as well as the column names. Okay, so this is all about the data validation. So as you can see, it's just a simple task. Okay, so data validation to be true. So you can now clap for your hands, clap for yourself. So this is okay. So after this, we can then push this to the Git repo. So git add. So git add dot. Then git status. So let me see if we are going to commit. So as you can see, we are only going to we modified the config.yaml. The new file that we created is this, and we also modified the schema.yaml file. So I think that is okay. I think let me complete until the main.py. Then from there we can do the commit. So let me unstake this. I think it's git restore. If I'm not git restore, it's supposed to be git. I usually confuse between git restore and so git restore versus I think it's git reset. Git reset. you need to reset the unstaging. Okay, so git reset and stage changes after the reset schema.yaml config.yaml. This one and this one. Okay, no problem. So you can see everything is running okay. And even if you go to the logs, you can see that also getting the same information about that. So let me convert this to the modular coding. Then after that, we can then do the committing. Okay. So actually it follows so the config, we already did the config. We also did the schema for the parameters until we get to the model trainer. Yeah, that's when we'll modify the parameters. At the moment, let it just be like this. So the next thing is about entity. So we go to our entity configuration entity. So we need to copy the entity. So entity configuration entity. So this is the entity. So data class and all this information. So we're going to copy this, going to configuration entity. Then we create. So this one is a data validation entity. So here we can data class validation entity, define the path to the data validation configure. We can just do away with this. Don't need it. So data validation entity. So data class, data validation entity, data ingestion, data validation. So that's the entity. So entity configuration entity. Once we are done, we can just do away with it. Then configuration manager in the SRC folder. So SRC folder, we do have the data validation the configuration manager. So the config, this one. So we need to update the configuration manager here. So for the config, again, go back to data validation. This is the configuration manager. So just going to copy all this. No, this one is already there. So we are just going to copy, I think it is this one. We're only going to copy this. So we already have the configuration manager and data ingestion config. We already have data ingestion config, done ingestion config. So we only need to copy the data validation config and import the data validation. So entity, then now you can say data. Can just copy this, copy and paste it here. So data validation config. Yeah, so we have imported the modules for that. So we can save this. Data ingestion config, data validation config. So that's okay. So data validation, no, configuration. So configuration, that's okay. So after the config, we go to the component. Okay. So in the component, that is the data validation component, data ingestion. So data validation component. So this is the data validation component. So we copy this class. So the entirety of this class. So data validation component, data validation component. Then there are some things like the logging, data config that we need. So say import OS. We need the logger. So from src.electricity bill import logging. We need the logging. Logging. Then you can see we need the pandas library. So from pandas import from no. So import pandas as PD. Then data validation config. So data validation config, then so from src.electricity bill config, so that is in the entity. Entity config entity configuration entity. We're going to import data validation config. Any other thing that you are missing? Anything? We are not missing anything, so that's okay. So that's the component part. So component part is actually the enforcer of the instructions. So here we're just getting methods or functions that carry out the necessary type, the necessary instructions. Okay. After the component, we then go to the pipeline. So component, we are done. Config, we are done. We go to the pipelines. So pipelines, we go to data ingestion. I think it's this one. But first, let me rename it. I'm just going to say this is pipeline number 2, data validation. So this is what we are done with. Data validation component, I don't need it. So data validation pipeline. So pipeline, for this pipeline, we can say we're going to import the necessary modules for that. Just copy this data validation pipeline. So here we need the configuration manager. Instead of data ingestion component, we need data validation. So C02 data validation. We don't need data ingestion, we need data validation. Logging is the same. So we can call this pipeline number 2. We can just call this and copy this data validation. So the first name is the data validation. So this is the data validation pipeline. So class data ingestion, so we can just change this to validation. A data validation pipeline, def init.path. So def main self, so configuration manager, a data validation config get. So this one can just copy this. I think up to here. So configuration manager, data validation config. Maybe you can just do away with this. Don't need this. But these instructions, you can get it from the when we're doing the experimentation, the research. So data config data get, okay, config validate all columns, validate data types. So if __ main, try logging info pipeline object data validation pipeline, this one here. Then pipeline main logging info. Okay. We can add a little bit of stars here. So terminated successfully, pipeline terminated. So data validation pipeline terminated, started, terminated. Then exception.py, that's okay. So after this, schema, we already updated our schema. Config.yaml, we already updated our config.yaml, so we can just do away with this. Data validation, I think we have done with it. So we need to go to our main.py. So main.py, and then we need to, I can just copy this because we are almost repeating the same thing. So component, that is should be data validation component. So component name data validation component, this one remains. So login info, so pipeline data, this one validation pipeline.main object.info info. So we need to import this one. So src so until here it will be the same. Pip2 data validation, import data validation pipeline. So this one is this, and that's it. Component name, so okay, I think everything is okay. Let's try to execute from the main.py. So python main.py, we need to get the almost similar results as what we did here. Yeah, so I think this is the data ingestion component. So this is the data validation component. As you can see, we have, when you start getting such things, then your code is working okay. So we have successfully converted our code into the modular coding. So then after this, now we can do the git push. So just do cls. So git add dot git status. Git status, you can see the files that we modified and the files that we added. Then after the git status, we need to git commit. So git commit -m, here we can say data validation complete. Data validation complete. Git commit -m do not match. Git commit -m data validation complete. I supposed to be -m without a space. Then git push. Git push -u origin main. Yeah, so let's check that. So data validation. So let's see. Can check under the src folder. You can see we have the data validation. Data validation. You can see data validation under pipelines, commons, data validation. Yeah. So everything is okay. Everything is okay. Now, so that was all about the data validation. So this section, we were able to do the data validation where we were validating the schema. The schema is nothing but just the column names and their respective data types. Okay, so we're just confirming that if we are going to we need the config. So we are just saying that we are creating a root directory that will store the necessary files. And under the files, we are going to get we are going to source for this folder the electricity bills data set under the data ingestion. This one. So after we get this, we are going to check if we have the said number of columns using this method, and we also have the said number of data types of the same data types as defined in the schema. Okay, so after that, using those methods, we are able to execute that, and we found that yes, indeed, our file contains those things. So it was validated. So the next step, then from here, then move to the next step, which is about data transformation. So we are going to do that in the next step. So that's all for this session. Once again, thank you for your time. Thank you for finding time to watch this video. I'm very motivated by you taking time to watch this and maybe say something about them. So I'm going to stop at this point. Then I'll continue the session, the next one, where we will be doing data transformation. Once again, thank you for your time. Please remember to subscribe, share it with your friends, like, and also leave a comment behind if you have something. Then we'll try to get back to you. So until next time, see you. So what's up, guys? Let's continue with the next component. So we have been building an end-to-end machine learning a model that can be used to predict electricity bills. So we started with the data ingestion, data validation. Now we are at the data transformation stage. Okay, so we are going to start with the data transformation. So if you haven't watched the previous things, 2 or 3 videos, you can also find time to watch them so that you gain a better context of what we are doing. So this is the data transformation stage. So we are going to see how we can do data transformation before we train our model. Okay, so when we are building the model itself, so you can see here that our data contains we have floats, we have integers. So when it comes to data transformation, then we do need to convert these categorical values we convert them to numeric, or we substitute them with numeric values, convert them to numeric values. And in our model, we did that using the one-hot encoding. So the same thing that we did when we were building the model, we're going to repeat the same thing under the data transformation. So one of the things that we will be doing is the one-hot encoding to try to convert those categorical values to numeric values, because our machine learning algorithms, they do accept numeric input. Also, another thing that we will be doing is the standard scalar. As you can see, before training our model, we scaled our data. Also, that's another thing that we will be doing in addition to other things, let's say imputing and all that. So all those things will be happening under the data transformation. And also, we'll also be doing a train test split under the data transformation. We also obtain some artifacts, the training data, the testing data, okay, transformation of those. So those are some of the artifacts that we will be obtaining under the data transformation. So stick around as you stick around, and you will see how we are going to perform those operations. Okay. So before we get started again, please consider subscribing. Hit that notification bell so that you never miss any of our video updates. You can also like this video and comment. We'll try to get comment if you have any query about any question, and we'll try to get back at you. Okay, so let's get started. So we're going to start with the data trans. So I'm going to create another folder under the research. So this is just the experimentation section. So we do the experimentation like prototyping. Then from there we can convert our code into the modular coding structure. So this is the part 3, where we will be dealing with the data transformation. So data transformation.py. So with the data transformation, so we start as usual by importing the necessary libraries. So I'm going to import OS. So again, I'll import pandas. So import pandas as PD. Import numpy as np. We'll also import joblib. Import joblib, import path, pathlib, import path. So this one should be from pathlib. Okay, so from pathlib import path. We're also going to import the data class. So from data classes, import data class. Also, we are going to import the logging. So from src, so dot electricity bill dot this one cc bill. So import logging. So we're also going to import, so in terms of utils and everything, commons, we are going to import save objects. So there are objects we are going to save. Objects. So we are also going to import from the scikit-learn library. The scikit-learn library. So I'm trying to group these libraries together. We are going to import the 10-test split. We're also going to import the column transformer, pipeline, simple imputer, and the standard scaler, as well as the one-hot encoder. Save objects. So data transformation. Save objects. So we also need to import the schema and all those things. We are going to import constant config path, params, schema, YAML, create directories. Okay. Data transformation configure. Okay. So let's start with the data class. So up to here, the first things are just common things that we have been doing. So we are going to data class. So at data class. So for the class, we are going to form a class for data transformation. So data transformation config. So here, data transformation config will be the class that will be holding. Will be the class that will be holding our the necessary file paths and everything. So when we talk about the file paths and when you talk about file paths, we go to the config.yaml. Under the config.yaml, we are going to define these necessary paths. So this will be the data transformation. So let's define the paths. So data transformation. Under data transformation, so root directory. So our root directory will be artifacts. it will be artifacts data transformation, and then the data path. So we need to define some data paths. So data path artifacts data ingestion electricity bill.csv. So that's the data path. Then we do have, remember, we do have numeric and categorical columns. So numeric columns. So in the data transformation, we are going to do some we are going to split all these columns, numeric columns. So the numeric columns, so we are going to specify those. So under the numeric columns, there's one thing that I need to specify here, is that when specifying these numeric columns, we are going to refer all those columns except one column, and that is the electricity bill column. It won't be, we won't list that column at the moment. And the categorical columns, so these ones we are going to specify. This is the city and company categorical columns. So city, company, these are the categorical columns. Traffic rate, monthly, month, motor pump, monitor, television, air conditioner, refrigerator. Those are the numeric columns. So you'll see why we are trying to separate these columns into numeric and the categorical columns. Okay, so you just see that. So under this, we need to specify those paths. So root directory, that is the path. Then our data path, again, this will be something like a path. Then the numerical columns. This one will be something, it will provide something like a list. Then categorical columns. This again will be something like a list. So you need to make sure that we don't need this. Data validation, we don't need this. Main.py, we don't need this. Electricity bill prediction, again, we don't need this at the moment. So data transformation, we need this. Config, so you just make sure that the categorical columns, so that you are not getting some errors. So you need to make sure that the spellings and everything is okay. So just to confirm, numeric columns, just to be sure, need to avoid unnecessary errors. So data class, data transformation config. So we have specified that. After this, we are going to create a configuration manager. So class for the config manager. So the class for the configuration manager. So we are going to create this. So for the configuration manager, remember this is just the same thing. We are not trying to change anything. So if you go to your data validation, our configuration manager is just the same thing. We are not trying to change. This is the configuration manager. So we're just going to copy this. So there's no need of typing that information again. Okay. So class configuration manager. Here we list the file paths and the schema, everything. So we updated our schema. In data transformation, we don't have a schema, so we won't be dealing with that. Then after this, we need to get the data transformation config. So I'm going to get the data def get transformation get. Okay, these things just come like this because I've used them more and common. I've used them often, so I think it's just using my past coding structure to just bring these things forth. So for the config, self.config data transformation, that's okay. Then after here, we create our directories. So we create data, no, we need to create the directories. So create directories. Yeah, create directories. Then we can say config root directory, root dir. Yeah, that's okay. Then after this, we need to now after this we need to create and return the data transformation config object. So create and return the data transformation config object, data transformation config. Whatever we are listing here, it's just the same things that we list under the data transformation config. So that's just the same thing. Okay, then we are going to return the data transformation config. So those are just the common stuff. So I think up to now you fully understand these things. So there's no need to explain over and over again. So after this, the next step is about creating a class to handle the actual data transformation process. So here we're going to do several things. So I'm going to create the first class. So class, nope, no, don't need this. We need to create a class. So class data transformation. So this class is going to handle the, now this is the supposed to be trans. We are going to handle the actual instructions that we have provided. So def init, then I can just do away with this to here. And self, that's okay. You can just do away with this. Then we can say self.config, self.config, then config. So that's self.config. No, there's something we are not adding here. Need to add the configure data transformation config. Yeah, this one. So self config. So with this, document can explain. So look at no, we needs to complete. Anyway, no problem. So config. So after this, we need to start actually with the coding part itself. So let's start with the so def get the transformer object, transformer obj self. So here we are going to try to do some manipulation data transformation steps. So I just do the pass first, then accept as supposed to be exception as e, accept exception as e. So that's accept exception as e. Then you raise e. That's okay. So the pass. So let's start now. We need now. Remember, we did separate our columns into the numeric columns as well as the categorical column. So let's call that here. So separate the numeric and categorical. Because when it comes to data preprocessing, they will require different preprocessing steps. Okay, that's why we need to separate them. Then after this, we are going to create a pipeline for numeric columns. Because numeric columns will have different type of data preprocessing. Because, for example, for the numeric columns, we don't need to apply the one hot encoding. Okay, so that means it will be different from that of the categorical columns, which require the one hot encoding. For the numeric columns, either we can just apply the simple imputer, as you can see, the standard scalar, and any other thing. Okay, so for the simple imputer, we imported the simple imputer, this one here, simple imputer. So we are going to use that, the simple imputer. So simple imputer, if our the columns are containing missing values, then we're just going to use the simple imputer, and the strategy to fill those empty values in the respective columns will be the median. So it will calculate the median value in the specific column and fill those empty spaces. So numeric transformer pipeline, and then we can state the steps. The steps start with the simple imputer. Then after you're done with that, go to the standard scalar, and that's it. So that's for the numeric transformer. So after this, we go to also create a pipeline for the categorical columns. So I like this one being here. Then just to create some separation. Just add an indent here. Okay. So then we can need to create a pipeline for the categorical columns. That's okay. Then again, categorical columns transformer pipeline. Then the steps, that is the imputer step again. Strategy, we are going to use let's use the most frequent. Then fill value missing, that's okay. Then for the one hot, after that, we should do the one hot encoding, then handle ignore. So that's it. So that's the categorical transformer, and this is the numeric transformer. So that's why you are trying to do that separation. Okay. So the separation, it has really helped us to handle the columns separately, depending on their data types. Okay. Then after that, we can then merge these columns together, do something like a concatenation. So combine the numeric and the categorical pipelines together. So here we'll need a preprocessor. So we create a variable preprocessor, and then we call that column transformer. So remember, we initialized our column transformer. This is the column transformer. So we imported that. So after importing the column transformer, this is the column transformers. Then the numeric, then you say, okay, no problem. Numerical, let's say numerical. And this one, we can say categorical. So numeric, then numeric transformer, numericals, categorical transformer. So for the numeric columns, we are going to call the numeric transformer. Then this is the numeric transformer. Then you are telling our code, we have listed some steps in the numeric transformer. Please ensure that you follow those steps while doing the data transformation. Then for the categorical columns, again, we have listed some steps. That is the imputer and the one hot encoder. Follow the same steps. Okay. Then after you're done with that, you're going to combine this. Then there is one thing that we need to, for example, let's say you have columns that you're dealing with the data time information. So as you can see here, we have not listed any columns that has we are not working with data that contains date information, or date or time, something like that. It's only integers, or for example, integer or a float, or object which is just something like a string. So if you do have columns that do contain a date, or for example, you have stated that I don't want you to touch these columns. Okay, so the remainder, that's what the remainder, this remainder comes through. It will form our transformer object that you don't necessarily need to interfere with these columns. So just pass through all those columns that we have left them. We have not defined them in any way or shape or form. Then after this, we are going to return the preprocessor object. So we are going to return the preprocessor. So the reason as why we are returning this preprocessor, we are going to be using this preprocessor after we have split our data into the training set and the testing set. Because remember, in the scalar, for example, there is a way you scale your training set, and there's a way you scale your testing set. So you will see how we are going to apply this preprocessor to our training set and the testing set. Okay, so that's all about getting the preprocessor object. So after we have defined that, we need to do another thing, and this is about doing the train test splitting. So we are going to split the data into training and testing sets. So so here I'll just say train test splitting. Let's call the function train test splitting. So we are going to split our data. So let's say self. So we are going to split our data. So again, I'm going to try block pass. Then we can say except exception exception as e. Then we need to raise e. That's okay. So under this we need I'll use a logging.info. So we can log a message to say we're going to log a message to say something. So let's say data splitting process has started. So started. Yeah. So it's supposed to be logging the double G. So logging. So the process has started. So I'm going to call my data. So df pd dot. I'm going to read the CSV file. Underscore CSV. Read CSV. Then we are going to read the data. So self dot config dot now the data path. So it's going to read the data from the data path. So our data path, when you go to our config, then the config.yaml, we have specified that our data path is in this section or this folder. So it's just going to read this, then it will guide that to the data ingestion, artifacts, data ingestion, electricity bill, dataset.csv. So it's going to pick that data from there. So that's this line of code that it's going to be doing. Then we're going to split our data into the independent and the dependent features. So we are going to drop. So here I'll just specify columns. Then we are going to drop the electricity bill column. So we are going to drop that. So we can just say this and that. Okay, so df.drop columns electricity bill column. Then our y will just contain the electricity bill column. Then after this, we can use another logging .info. Here you can say splitting data into training and testing set. Training and testing sets. So splitting data into the training and the testing set. So let's see. So xtrain, ytrain, the same thing. So splitting our data into xtrain, xtest, ytrain, ytest, train test split. Remember this, x and y. Test size 0.2, random state 42, no problem. So this is okay. You can use 142, 127. It all depends with what we are using. Then we can also do some logging information. Then we can say logging So logging.info. Then we can, after splitting our data, we can save the training and the testing sets artifacts. So we are going to saving the training and testing data in artifacts folder. So save, can say save the target variable. So I'm going to save the target variable for both training and testing. Okay, so you can say y_train dot to underscore CSV os dot path dot join os dot path dot join brackets self dot path dot join self dot config dot root directory dot config dot the root directory. So root directory, and we're going to save this as y_train dot CSV. Then we need to say that we don't want the index. Okay, so this is the training set. This is supposed to be false. False. So the same thing, we're going to do the same thing for the y_test. So y_test to CSV os.path.join. Okay, so you might wonder as to why. Okay, let's just add them before I can explain. So we have the training data. So you can say xtrain. Okay, so save the target variables for both training and the testing set. So you can see the y_train and the y_test. So after doing our split, we have the xtrain, xtest, xtrain for training, xtest for testing. Okay, so we are saving the y_train and the y_test. So these are the target variables for both training and the testing set. And here we can also save the training set, the training set data for both training and the testing set. But I won't be returning this simply because we are going to do some transformation on the training data as well as the testing data. So I don't want to save them yet, okay? Because if I save them, then I need to again import them, which is quite laborious. So I don't want to do that. Then what I'll just do is add some logging information. So logging, splitting the data process has completed. Then we can do return. We can return. So I'm going to return the xtrain, xtest, y_train, and y_test. So I'm going to return all this. But remember, if I'm returning this, I'm not saving those data frames for the xtrain and the xtest, because we are going to do some data transformation using the preprocessor. So there's no need of saving those yet, like at the moment. So we'll save those after we have done the transformation. Okay, so this is about the training test splitting. Now we are going to initiate the data transformation. So we are going to initiate the data transformation. So you can just say initiate data transformation. So instead of self, again, we are going to say, we are going to call, so whatever we are returning in our previous method, we are going to use that as parameters in the next method. So here, now this method is where we are going to do the actual data transformation. So again, I'm going to say try. So logging info data transformation. We can just solve this problem. So logging info data transformation process has started. Then we are going to get the transformation object that we created earlier. So that's what we are going to do here first. So after we get the transformation object, so that's the preprocessor object, self.get transformer object. So this one here, transformer object, the preprocessor here, self.get transformer object. So once we get that, we need to transform the training and the testing data. Transform the training and the testing set data. So transform the training and the testing set data. So those are now the xtrain and the xtest. So we can say xtrain transformed, and then the xtest transformed. So xtrain transformed and xtest transformed. Okay, xtrain transformed, xtest transformed. So in the training set we are fitting then transforming, but in the xtest, the training set, we are only doing the transforming only. So you need to know that. Then after this, we need to save the preprocessing object. So save the preprocessing objects. So we need to say the preprocessor path. Save. Can say save objects, something like this. Something like this. Save objects. No, we need to use joblib, or we can say preprocessor obj object dot joblib. I like joblib because if we are creating a sparse matrix, and joblib is quite efficient in ensuring that even though we are creating a sparse matrix, we are trying to create a sparse matrix with a that is small in terms of size. Okay, so save objects. Remember, we called a function here, save objects. Okay, so that's what we are using here. So preprocessor dot this, save objects, preprocessor dot this. So that's okay. Let me try something. Okay. So preprocessor object, os.path.config root. This one, then self.config. So after this, we can do another thing, that is now save the transformed data path as arrays or sparse matrix under the .joblib format. Okay, so we can save those now this as array object. So xtrain transformed path. You can just say as and say sparse matrix. So xtrain transformed path. This will be os.path.join, and then self.config root directory. Then here we are going to call xtrain transformed.joblib. xtrain transformed.joblib. Then it's supposed to be in quotation marks. Xtrain transform.joblib. So that's for the training. For the xtest, again, it's just the same thing. Xtest transformed path, os.path.join to self.config root directory, xtest transformed.joblib. Then we can say joblib.dump. So joblib so it needs to dump these files. Xtrain transformed, xtrain transformed in the xtrain transformed path, and also joblib.dump xtest transformed in the xtest transformed path. Then we can also include some logging message, info data transformation process complete. Then we need to return something. So we can return So we can return the xtrain transformed, xtest transformed, ytrain ytest. You can also return the preprocessor path. We need to save this into some preprocessor path. So preprocessor path. Let's say quest.path.join. So this is the self.config.root directory. Then you can call this the preprocessor wlib. Save objects preprocessor. Then we can save this as an object. Supposed to be save objects. Let me confirm something. Preprocessor objects. So this one is supposed to be preprocessor obj object, and the preprocessor underscore object. So it's obj. So that's okay. Then there is something. Save objects. Why are we not calling that save objects? That's okay. Then we need to call our preprocessor path. There's something we are missing. That's why we are getting this error. Exception. Oh, this one. Having this one, yeah. So that's the data transformation. So after, then we can then to the pipeline. So for our pipeline, we can so if underscore name underscore then underscore main underscore then what you can say about this is try block. No, we don't need this one at the moment. Okay. So config. So we first initialize the configuration manager. So configuration manager. By initializing that, we get the data transformation parameters. So data transformation config, data config.get transformation config. Then after this, we need to initialize the data transformation class, data transformation. That's okay. Data transformation config, data underscore transformation config. That's okay. Then after that, we need to get the splitting the data. Xtrain xtest, we split our data. Data transformation obtained. Okay, that's okay. Then after this, we perform the data transformation. Xtrain transformed, xtest transformed, ytrain perform data, no? xtrain test, xy train splitting. After we have done the splitting, we can perform data transformation. So we can what we can do, we can do this. Say train a data path, test data path, test data path, or we can just say test data path, train test path, y train data path. I'm going to say y test. No, you can just say y train data, y test data, y train data, y test data. Then we process a path. And then you can just do the data transformation, then dot initiate data transformation. Then here we can pass in the arguments, which is the xtrain, xtest, y train, and then y test. So let's try to do this. Try to correct this syntax. Let me try something. And just add that path by train that path y test data path. So processor path hyphen, then you can add this data the one thing that I want is to use this gives the forward slash. forward slash, I think it's now okay. I think if name underscore main. So I just wanted to use this slash so that we can slash this code is quite lengthy, so it can fit. I think with this we are okay. So let's try to, we have the main, so let's execute this. So new terminal, the new terminal, what we are going to, so Python, then data transformation, copy relative path, paste it here, make sure you have saved your code, then execute. So we need to get an artifacts folder, and this artifacts folder, we need to see the xtest and the ytest, the xtrain.joblib and the ytest.joblib, something like that. So import the save name save job commons. Yeah, I think in the commons, so that is the utils. You can go to the utils commons. We have save object, not save objects. Yeah. So it's supposed to be save where. So just change in the data transformation. So you can just change save, instead of save object, supposed to be save object. Then at this point, just change this to save objects. So we can save this. Then Control C, we can then execute this. That was just a slight error. Save objects. Cannot import the name save objects. Yeah. So let's see if you're going to get something from this. So the data ingestion and the data transformation, they are quite intense, resource heavy, because they involve a lot of, okay, you're getting an error. So repeat error, non-type object. So splitting data started, data transformation to this. So we are getting an error. Data xn test data transformation to 10 test splitting. So this is in the line number 176, 170. Let me just cross check. So initiate transformation, preprocessor object, self.get transformer object, xn transformed, fit transform xtrain, xtest, preprocessor object, pt.read, self.config data path, data path, self.config data path. Data path. So 1, 2, 3, 4. it's supposed to be for list path. Okay. So again, indentation error, this one here. Get data transformation. Then why is this not responding? There's some issue here. So get def is supposed to be the same, and this one should be get root directory. So get, let's see. I think I was not returning the data transformation config, if I'm not wrong. Let's see if the error is now resolved. So you need to be very careful with your code to just avoid these small issues. The problem is that even a single comma is going to bring you some huge challenges. So you need to be very careful with that. Yeah, everything is okay. Now you can see now our data transformation is working okay. And see, created the directory artifacts, created the directory this. Data splitting process has started, splitting the data into training and testing set, saving the training, okay. Data splitting transformation process has started, data transformation process has completed. So we had an issue with this. We were not now, after creating the data transformation config, we were not returning the transformation config object. We are not returning that. So that's why it was not. So when we come to this section here, data transformation, I think return data transformation, I think this one. So it was not going, it was not finding it. Okay, that's why it was printing that error. But up to now, you can see everything is okay. You can go to the artifact section. So in the artifacts, you can see this is the data validation. I show you it is true. So data transformation, you can see we have the xtrain and the xtest. We have the training transformed data. We have the testing transformed data. And also we have the preprocessor object. So preprocessor object will be used. So the reason as to why we have saved the preprocessor object is because after the user has input data, so we'll build an app, something like that. So the user will enter the data. So that data has to come to the preprocessor object. So the preprocessor object has to process that data. Then from the preprocessor object, that data now comes through the prediction pipeline, where we get the prediction based on the user input. That is why we are using the preprocessor object. So for training our model, we need our xtrain that is preprocessed. We also need the training set that is preprocessed. We did not preprocess the ytrain or the ytest. So those will be used as the way they are in the CSV form. So we'll just import them as the CSV form. So it did not require a lot of transformation, okay? So after this, we need to convert our code into modular coding. So as usual, we are going to start with the entity. I'm going to close what is unnecessary. So data validation config, this one is okay. That's okay. Then we need to possibly, start with the entity. So entity configuration entity. So in the configuration entity, we are going to copy this, the data class, this configuration entity. So this entity, this is for data not validation, data transformation entity, data transformation entity. So we copy that, we save, then we can close this. So make sure you have saved and close this. So after the entity, we need to go to the configuration manager. So that is the config, config.py. So get data validation config. So here we are going to get data transformation config. Okay? So this one is the only thing that we're going to copy here. So get data transformation config. Let me try to see if everything is okay. So here we need to, now in the config part, component config, we need to import. So here as you can see path. So we need to also import path. So just import it as the first. No, I can just say from pathlib. From pathlib import path. Then we also need to do import the data transformation config. So this one we are going to so here you can just copy this. Make sure we are just insert brackets, and then this one you can just save it here. So when you save that, then you can see the error is not showing. Error is not showing under the configuration. So data ingestion config, data validation config, then get data transformation config. The rest will be about model trainer. So configuration done. Configuration done. The configuration, we go to component. So our component is the component number 3, data transformation. So data transformation, we just import the entire class for data transformation minus the pipeline. So you can just copy this data transformation, give some space, and then you can just copy that. So after this, we need to import the necessary libraries. So import OS, and so most of these things, instead of typing, we can just import them. I think this one, all of this is necessary. So import transformation, and import this. So data transformation config, we need to import entity from entity. So again, you can say from src dot electricity bill dot entity dot configuration entity, import data transformation config. Data transformation config. So we are done with that. Logging, so we need to import logging. So from src dot electricity bill, import logging. Supposed to be logging. So import logging PD. So we need to import pandas. So from import pandas as PD. Import OS pandas as PD. So that's okay. We also need to import joblib. Save objects. Need to import the save object and the joblib. So import PD. So import joblib. So joblib plain test. That's okay. We also need to, from commons, we need to import save object. So I'll just include it with these ones. So from src dot electricity bill dot entity dot it's supposed to be utils, dot commons. We're going to import save object. That's it. Let's see if we have any other thing that is missing. Something that is missing will just show itself. Data transformation config object. So data object standard scalar, one hot encoder, simple imputer, pipeline, column transformer, train test split, joblib, PD, OS. Yeah, I think everything is okay. So after the components, we go to the pipeline. So we are done with the components. We go to pipeline. So our pipeline, yeah, this one is the pipeline. So we can just rename this. So rename pip03 data transformation.py. So data transformation, don't need this one. We are done. We are done. So data transformation as a pipeline. So we are going to design the pipeline for that. So for the pipeline, data validation, you can just copy this first. Data pipeline. We need the configuration manager. Instead of data validation, we need data transformation. So that is C data transformation, import data transformation. Data transformation. We also need logging. We also need import OS. We also import from pathlib. Import path. So those are the required stuff. So we can just copy this, then we'll just make some changes. So this one, so our pipeline name is data transformation pipeline. So data validation, data transformation pipeline. So data transformation pipeline. So again, configuration manager. So the pipeline. So here we are going to try out something different. So class data transformation dev init pass. So main dev self main. So here, let's do away with this. We're going to try something else here. So dev. So try. So we open brackets path. So our path is the from our validation status. Artifacts data validation status.txt. So we are going to open this file, the read by as f, so that if this is true, then this process should continue. Read, then split this, then -1. So you can say that if status is said true, and say that were we getting true? Let's see. Status, if status is true, we're going to read that, and then supposed to be like this. True, then the data validation pipeline has been executed, and that is okay. So after this, we can log some info. If status equals to be true, then logging the data validation pipeline has been executed. Then we can start some logging.info. Then here we can state now we can start this process. Let's say so what's this one? Then we can say pipeline name. So we can say pipeline name started. Then can do this, say hash. Then you can say if the status is true. No, something I'm missing here. If it is true, it's supposed to do something. Let's see, let me try to here, then and say else. We're going to face exception. The data schema is invalid. Okay, so then the rest of this code should be inside here. So you can start so you can copy this. So data transformation dot save data professor. And also again use this. Nope. And slash this staying data test data path, staying data path test data path, then slash write any again we can slash, you can slash like this. It's You can just say store data. So this is the so need the else raise this, then we need the except blocker. Block except block print e exception as e. So else then we can also say login info data transformation. We need this one. So data transformation pipeline. Close this gap. So let me try to explain what we are doing here, so that we are in sync. Okay. So with the data transformation pipeline, I'm relying on the data validation status to ensure that we are able to execute this pipeline. So if you're going to execute this pipeline, you first need to ensure that our validation status is true, something like this. So we need to ensure that our validation status is true before we can even start so we need to ensure we are relying on the data validation before we can run our data transformation pipeline. So we need to ensure that our data validation status is okay. So that it means if the data transformation status is true, then we can raise a message to say that the data validation pipeline has already been executed successfully. So then from this, we can now start executing the transformation pipeline. So we log a message, transformation data transformation pipeline started. Then we config data transformation, this and this. Then now we can store our data. Then after this, if this is not true, else except you're going to raise an exception, and this exception will be that our data schema is invalid. So we need to correct that if that is the case. Then logging information pipeline terminated successfully. Okay, so that's it. Then from here we can use a data transformation pipeline. That's going to copy this data transformation pipeline, terminated successfully. So pipeline started, transformation successfully. So do I need this one here really? I don't think I need this. This is supposed to be in the main.py, if I'm not wrong. So print as e. So this is a data transformation pipeline, data validation pipeline. So for the data transformation pipeline, I don't think I need the if else here. Okay. So I'll just go to the data transformation. So to the main.py. So main.py. And in the main.py, I can just copy this. So component name data transformation component. So data transformation component if this and this started. So pipeline data validation pipeline ingestion.main, logging this information, this. I think this one is okay. Let's see. Let's run the main.py to see if we are going to get our data. So Python main.py. Let's see. Python main.py. So oops, so this and this are just the same thing. It's something I haven't done. So we need to data transformation. We need the data transformation pipeline. So the main.py is supposed to be data transformation pipeline. Then we need to import that here. So from src.electricitybill.pipelines pip number 3, pipeline number 3. We're going to import data transformation pipeline. So this one here, this. So let's run this again. Let's see. Yeah, I think it's now running okay. Data transformation has not saved that. Either way, data transformation object has no attribute save data. Either way, no problem with that. So data transformation component terminated successfully. So we are able to execute that. So okay, so I think that's it. So after this, we need to push. So git add dot git status. So these are the files. Git commit -m. So we can say data transformation. Data transformation complete. Data transformation complete. Okay, so and then after this, git push -u origin to main. Yeah, I think we're okay with that. So let's try to run this. So data transformation complete. Yeah, that's okay. This one is okay also. So if you check the logs, check the logs. The logs again, you can see now. See how your logs are looking okay. Okay, so this is how we do this. Okay, so that's it. So that's it for data transformation. So now you can see how you can do data transformation. So there are numerous ways that you can use in the data transformation. Of course, here we just used simple imputer and all that. So you can, for example, if you want to remove outliers. Okay, so before we do this, you can create another another method here to remove outliers. Remove your outliers, then separate the columns into this and this. Then you can also do the transformation. If your columns does, for example, our column, this one, sometimes your column does not contain categorical transformer, no, categorical values, then you don't need the categorical transformer. So you can just create this so that in case you need to scale your data, if now your data changes, now it reaches a point you need now to use your data might change, and in the process you might get categorical values. So you can just come at this section and just change this section here. Okay. So this one, another thing about data removing outliers. Another thing is about let's say if you want to use the PCA again, this is the section where you need to introduce that the PCA. So I think PCA will, if you're going to use the PCA, you're going to use that on the training set data. So I think the most appropriate section will be after you're doing the train test split, before applying this processor object to the training data, you need to pass that data through principal component, or you can split the data, apply the principal component. Yeah. So it all depends. It all depends. If you need things like the smote, if you want to, you have class imbalance, then this is the point where you need to achieve that. Okay. So I think we have tackled a lot of things under this. We have done a lot of things under data transformation. This is one way you can do this. You can add other transformation steps. It all depends on you. Or if you don't want to use the column transformer, you can use the make column transformer. So it all depends with what you want to do, or with the steps that you need to achieve for data transformation. All in all, that's all for today. Once again, I'm very thankful for your time. Please consider subscribing to the channel. Hit that notification bell so that you never miss any of our video updates. Also, please like this video and share with your friends. So until next time, I'll see you in the next video. So before we close, the next video will be about a model trainer. So I will separate model trainer and model evaluation. Then I think the other one will be using Flask to build an interface front. Getting the name. Anyway, that's it. See you in the next one. Bye bye. Hello everyone, and welcome back. So in this video, we are going to be continuing with our series. So in this case, we are going to be discussing about the model trainer, or the model training. In the previous videos, you saw how we did our data ingestion. We also did data validation to validate the schema of our data, that is the necessary columns as well as the data types. Then after that, we moved on to data transformation. So you saw the different steps or the techniques we used for a data transformation. So those are the earlier steps or the earlier components in our model. And if you have watched the videos, you can see how we were able to achieve those, and made sure that those components were running successful. So in today's video, we are going to start with the model trainer. So we are going to train our model. Then after that, we are going to now evaluate the model to see how it is performing in terms of making predictions on unseen data. So that's what we are going to be covering in this session. So once again, before we get started, please consider subscribing to this channel. We are welcoming you to this wonderful community. Hit that notification bell so that you never miss any of these video updates. Once again, I'm very grateful for your time. And with all that said, let's get started. Okay. So as usual, we're going to start by importing the necessary libraries. So as usual, most of these libraries, I think you have understood how we are using them in our previous videos. So most of these things we're just repeating and trying to add new libraries or something like that. So after this, so this is for mostly you can see that most of these, the data class and the partly, most of these are what comes next after this is the entity. So we are going to prepare our entity. An entity basically is a type of class that holds the paths to different files in our model. Okay, so we are going to so for our class today, this will be model trainer config. So just change here model trainer config, the model trainer config. And when we talk about the model trainer or this data class, when we talk about config, we are talking about, most of the time we are talking about the file path. So if you are talking about the file path, then the first step that we need to do is to go to the config.yaml file, and inside here we need to update the necessary paths to the necessary files and directories. So we are going to for today's session is we are going to be talking about the model trainer. So we set the paths for the necessary files. So model trainer, for the model trainer, again, so for the model trainer, we're talking about the paths. So we're talking about the paths. So let's configure that. So in terms of the paths, so the model trainer, again, the root directory. So that's the artifacts. So artifacts model trainer. Model trainer, then we'll specify the training data. We'll also specify the train data path. Train a data path. So for train data path, that will be artifacts. So artifacts slash data transformation. Then xtrain transformed. Xtrain transformed .joblib. In case if you're wondering where we are getting this xtrain transformed.joblib, so in our previous session we did the data transformation, and we were able to these were the artifacts. So the xtrain transformed data, the xtest, the ytest, and the ytrain. So after splitting our data, we had to preprocess our x training set and the x testing set. So after we did that preprocessing, we had to save those as our artifacts, and these artifacts are found in the data transformation in the folder artifacts data transformation. So you can just xtrain transformed. You can even just copy the file path. So copy the relative path. So we can just to be sure, you can just copy that here. Then that is for the training set. For the testing set, test data path. For the test data path, so that is the xtest transform. So we can just copy the relative path. Then if you just paste it here. So these are the necessary paths for our training data as well as the testing data. Then here also, remember, we are going to save our model. So model name. So for our model name, we are going to say model.joblib. Yeah, I think model.joblib. So that's okay. So these are the configurations necessary for our model trainer. So we can go back to the model trainer. Let me just so for our model trainer config.yaml, so we updated that. So then whatever we did in the config.yaml, we are just going to be repeating that in the model trainer. So the root directory, that's the path. Then the train data path. Train data path, again, this is just, it will be the path. Then the test data path. Oops, it's supposed to be in a new line. So test data path, again, this will be the path. Then sorry, then the model name, this will be a string. Okay, then at str, then there is one thing that we need to include, that is remember we're using the decision tree regressor, decision tree regressor. So decision tree regressor parameters. So this is where we are going to include the different parameters for our decision tree regressor. So if you're going to include that, then you need to go to our params.yaml. Okay, now you can see how from here, we're going to update our necessary parameters for the decision tree algorithm or model. So for the decision tree, so we are going to name our regressor. So that is the decision tree. So decision tree regressor. So for decision tree, I think I'm naming it. Okay. So we are for the decision tree. So let me try to the decision tree, we can let's say decision tree regressor scikit-learn. So in the decision tree regressor, when you go to the decision tree regressor from the scikit-learn, you can see the different parameters required for the decision tree regressor. So these are the parameters that you are going to specify. So you are going to specify the parameter as well as the value for each parameter when for the decision tree. Okay, so I've selected a few. For example, the criterion. So criterion squared error. For the splitter, this one I've specified that best. Then for the minimum sample split, this one I've specified the minimum sample split, that is 2. Then for minimum sample leaf, that is 1. Then you can also say random state. The random state, I've specified no value for this, so I'll just state null. You can include any value that you want. Okay, so for the maximum features, this one is log 2. The maximum features, that is log 2 maximum leaf nodes. The maximum leaf nodes, that is again null. Then for the minimum impurity decrease, minimum impurity decrease 0.0, so that's a float. Then CCP alpha. The CCP alpha, we can say 0.0. Okay, so these are the hyperparameters, and I've specified the hyperparameter name. So that's the key and the value attached to that hyperparameter. So whatever these hyperparameters I've listed here, I'm just going back to the config, the model trainer. Then I'll just sort of list them here. And instead of this, the values, I'm just going to specify, for example, if this is a string or a float. So for example, this is a string. So I'll just call this as a string. Then for the best, again, this is a string. For the minimum sample split, this is an integer. This one is also an integer. For random state null, random state, let me do away with the random state. Max features, do we need this? For integer, then max impurity decrease. For the meantime, let me deal only with this. This float. So this, let's say this is a float, and also this is a float. Okay. So string, integer, float. Okay. So you can see how we specify the different types of. We can specify now the different hyperparameters for that. Then after this, we can also import the other libraries. So for example, we can import the config file, the params file, the schema file, the read YAML, okay, the save JSON file. So we can also import that. So that is the after component. I think we are going to the config. So under the config, you can just it's essentially the same thing. So the configuration manager, class configuration manager. So I just copy this. So this is the common stuff. So the configuration manager, class configuration manager. So that's okay. So from here, configuration manager, initialize the configuration manager, create, okay, that's okay. Then we need to add something here. So we need to get our model trainer. So we need to first get our model trainer. So def get model trainer, trainer config, get model trainer config self model trainer configuration. That's okay. Then here get the model trainer configuration config self dot config model trainer. That's okay. We also need the parameters. So self params model trainer params. So instead of model trainer params, we need to specify that here we are dealing with the decision tree. So decision tree regressor. So for the regressor, then we also need to specify the schema. Under the schema, what we just need is the target column. So if you go to our schema, the schema, we only need this target column, okay, to specify our target column. So get the model trainer configuration config. That's okay. Then after this, we can create the directories. So we create directories. Directories config root directory. That's okay. Then create and return the model trainer config as an object. So whatever we are specifying here is whatever we have listed under the entity itself. Okay. So the root directory config the root train test model name. You can see root train test model name. Also this model name, criterion splitter, mean sample split. All these parameters are the hyperparameters that we specified under the decision tree hyperparameters. So after this, we need to return. We're going to return model trainer config. So that's it, model trainer config. Also, when running this, I encountered a challenge that necessitated me to also include the data transformation config, the data transformation config object here. So I'm just going to copy this config into the data transformation, into the model trainer, sorry. So you can just also add this configuration here. Okay, so because we also need this, and we also need to import the data transformation config. So I'll just import it here. So from src electricity bill. No, this one is from this one is from research. We don't need SRC here, so we are importing this from research. So remember, at this point, we are not. We need to do the experiment, test our code, see if it is running okay. Then we need to, after that, we convert that to modular coding. Okay. So here we need the data transformation config. This one here, data transformation config. Okay. So after get model trainer, I think the next step is about now we'll import other modules for this. For example, we'll import for the class that is going to handle the necessary data, the training part. Okay, so we're going to import the pandas, import OS, logging, the decision tree regressor itself, joblib, and these metrics. So these are the evaluation metrics that we'll be using. Then data transformation component from the research. Okay, so again we are going to create our class. So class model trainer. So class model trainer. Then in our model trainer, def init self config model trainer config. That's okay. And then self config. So we just want it up to here. These ones are this is relevant. So self config, that's okay. Then after this, we need to now initiate the model trainer itself. So def initiate model trainer. Initiate model trainer. So self xtrain transformed, xtrain transformed, xtest transformed. We also need the y train, so we need the y test. So that's it. Get model trainer, ensure everything is perfect. Then after this, we need to initiate the model. So the decision tree model. So our model itself. Then that's the decision tree regressor. And inside here, we are going to include the different hyperparameters. So these are the parameters. So criterion, self.config criterion. So whatever we are listing here is just the same thing. This one here is just the same thing here. So we're just lifting this and pasting as our different hyperparameters. So when this model is executing, it will refer to this. Then from here, it will come to this place. Then from here, it's going to refer to the params. Then it's going to the parameters file. Then it's going to read the value from here. Okay, so that's what it's doing. So these are the different type of parameters. So the decision tree model, so we are going to fit, and in this case, I'm just going to only do the fit and not the prediction. So only the fit. Then we create another code for the model evaluation. So I thought that if I'm going to, it's better to separate those two, because if I'm just going to change the model, I will just go to the parameters, change my decision tree regressor model. Maybe if I'm going to use the random forest, just change the decision tree regressor model and the different hyperparameters for the random forest, if indeed I'm going to use the random forest. Then after that, I'll just go back to my model trainer and just maybe change the little things concerning the decision tree regressor. Then I won't need to change anything in terms of model evaluation. So from here, I'm just going to dump this model. So joblib So joblib dot dump. I'm going to dump, so that's the DT model. So os dot path dot join. So self dot config dot in the root, so it's going to the root directory, and in the root directory self dot config dot going to name according to the model name that we have specified. Okay, then after here maybe we can specify some logging information. So logging dot info, and say logging info. So for the logging info, model trainer process has completed. So we can say saved to, then we can say to os.path. So whatever, this one here, we can just copy this and say that it has been saved at this location. So we need to do something here. So wait a minute. Model trainer process has completed. Then it is saved to, supposed to be os.path join. Then need to include brackets here. There's something I'm missing. We need to, yeah, use the F string. Model trainer completed, saved to this path. Okay, so we're just passing the path. So logging info, model trainer completed. Saved to this path. I think that's okay. That's okay. Then we can then create our the pipeline. So for the pipeline, pipeline if underscore name, so configuration manager like this, then model trainer config.get model trainer. Okay, so that's okay. Then data transformation configuration. So that will be data transformation config.get, supposed to be config.get data transformation config. Get data transformation config. It's supposed to be having this here. Then data transformation. For the model, for us to conduct the model trainer, then we need to import the data transformation config first. Then under that we also need to show that we have done the X test and the Y test, train test as split. That's why we imported the data transformation config. Let me try to zoom in. So configuration manager, model trainer config.get model trainer config. Then data transformation config.get data transformation. So we are getting that from the data transformation. Then under the data transformation, we need to show how we are going to import that, and from there we need to show how we did the data transformation, and especially the train test split. Then from there we need also to include the transformation of the data. So I'm going to import that again. So for the transformation of the data, xtrain transformed, xs, that's okay. So, and remember, we're just doing the fit. We're only interested in the xtrain transformed, xs transformed. We only need that. We don't need the processor and all that, because in the transformation, remember this is what we are calling back, but we are only interested in this and not this one. Okay, so that's the model trainer, data transformation, initiate model transformer. Then after that, we need to do the model trainer itself. So for the model trainer, that's it. Let me try to. Yeah, so I think that's it. Then I forgot the try block, so try except block. So I'm just going to include that. So from here, we're going to say exception, except exception as in, then and just say raise e. Don't need the login. Yeah. So I think everything is okay. Xtrain transformed, Xtrain transformed, y test, that's okay. Model trainer config, that's okay. Yeah, so this is our pipeline. So I'm going to execute so that to see if you're going to get an output from this. So new terminal. In the new terminal, I'm going to call model trainer. So copy the relative path, Python Control V. So let's execute this one. The model trainer. So by this we are just training our model. Then from here we can move to the next step, which is all about model evaluation. So data ingestion, we are getting the data validation. We need to get another folder here for model trainer that will be storing our model itself. Getting an error, config box target columns. So artifacts target columns, key error target columns. Let's see. Target columns. So let's go to our schema. So schema supposed to be target column, not target columns. So it's supposed to be target column, not target columns. Yeah. So that's error. So corrected that. So let's repeat this again. So you can see the config box at its work. So we did not config box object as not target column. Let's see. In fact, this one, you can see. Let's try to edit that out. So decision tree, YAML file, target column key error. So config box schema.yaml, target column. back. You can see. Okay. Let me. Yeah, I think for the schema we need just to do away with this. Don't think it's needed at the moment. So you can just do away with the just do away with the target column here at the moment. Don't know why it's not working with the target column. Cannot understand why, but you can see our model trainer. We have the model.joblib. Okay, so that's okay. So model trainer completed. Save artifacts to this. That's not a okay. I think it's now working. Okay, so you can just maybe do away with the target schema when we are talking about when you are in the get model trainer config. Okay, yeah. So that's about the model trainer. So you can see how we did our model trainer. Let me just go back. So we started by importing the necessary libraries for that, created our entity where we specified the root paths to necessary files and data. Then from that we created the configuration manager. Then in that configuration manager we also imported the data transformation config. Then from there we did the model trainer. Then from the model trainer we created the class model trainer class, which is going to handle the training itself. So we created that, and then we saved our joblib file, our model in a joblib format. Then we created our pipeline, executed it, and this is the result, the model trainer folder containing the model.joblib. So the model.joblib and the preprocessor will be used when we build our prediction pipeline. So when you build that pipeline, as I said earlier, I think in the previous video, is that when the user inputs data in the web app, then that data needs to go to the preprocessor. So in the preprocessor, it will do the initial preprocessing of the data. Then after that, it will push that data to the model trainer. Then the model will use the data to now make the predictions. Then the prediction will be funneled out to now the user to see the results based on the input they have used. Okay. So after this, we need to convert our code to modular training or modular structure. For our modular structure, again, there is a sequence for that. Let me. There's a sequence for that. So the first is about the config. So we did the config.yaml, so that's okay. Then the schema, we updated our schema, that's okay. Then params, where we list our parameters and all that. Okay. Then after that, we need to go to the entity. So we are going to update our entity configuration entity. So this was data transformation entity. So this will be model trainer entity. So model trainer entity. So you can just save this. Then go back to our code, model trainer. So we can just copy this from here up to here. So this is the model trainer entity. So maybe you can just, okay, let's create that separation. So this is the the configuration entity for model trainer. Then after that, the configuration manager in the SRC folder. So config this one here. So configuration manager. Remember this one, we did use the get data transformation config. So we don't need to copy that again. I'll just copy this. Then return, yeah, that's okay. Then configuration entity. So remember, we already have the transformation config. So I'm just going to copy that for our model trainer. So maybe even we can add here model trainer config. This one is for data transformation. You can say data transformation config. Then this one is for data validation config. So as you can see, we are saving all our configurations in a single folder. Then we are saving all our entities again in a single folder. So the model trainer config, we are going to import that. So that is occurring in the SRC folder config. We are going to import our model trainer config. So again, you can just insert a comma here, say model trainer config. So model trainer config, that's okay. So data ingestion, validation, transformation, okay, that's fine. So you can see we are corrected that error, so that's okay. That's our config. So after the config, we go to the components. So in the components, under the components, we have the data. It's supposed to be model C1, C2, C3 transformation. I think this is the model trainer. So in the model trainer, we are going to copy our components. So components, model trainer. So we start by importing the necessary libraries from model trainer, this one here. I think we don't need the metrics here at the moment. We need the metrics when we are dealing with the model trainer itself. So I'm just copying everything up to and before the pipeline. I'm just going to paste them here. Everything up to until the pipeline. So we need to import the model trainer config. So we don't need the research here. We don't need this one. We don't need the research. So from SRC electricity bill, then entity, then configuration entity. We're going to import model trainer config. That's okay. So remember, this one, we are now converting our code to the modular code, so we don't need the research because it's not under the SRC folder. So this one is okay. I think we are done with this. So after the component, we go to model trainer, we go to our pipeline. So let me just do away with this. So we go to our pipeline. So in our pipeline, so under pipelines, we are going to create a new folder. So this one will be pip 0304 model trainer.py. So this will be model trainer. So again, we just go to our pipeline. Pipeline, so model trainer, model evaluation. So model evaluation, we are going to copy the necessary files. So for the pipeline, for example, we need this. Let's copy this, then we can just change them later. So pipeline, we need the configuration manager. Instead of data transformation, we need the model trainer, so C04. Instead of data transformation, we need the model trainer. Then we also need logging. Also, remember we also need the data transformation one. So data transformation, we are going to copy that. We need the copy this. So in the data transformation, this one will just come before. So see component 3 data transformation, import data transformation. I also need logging. Path, you don't need this one. Huh? Logging is important. Paths, yeah. Anything that will be important will also include that. So for the pipeline, copy this model trainer. So for the pipeline data, so this one is model trainer. Model trainer pipeline. The pipeline, so class model trainer pipeline, that's okay. Then def init self, then here we just do a pass. Then we define that. So whatever is under the, we're just going to copy everything here. So this is our pipeline. So this is our pipeline. Yeah, so that's okay. Then we need to add this, the if block. Okay. Underscore name. So main. Okay, so we try block. So logging info. So what we'll do, we will use an f string. Let's include this inside the brackets. Then we'll use an f string. Then so for this case, data transformation. So what we did, something like this. The trainer, something like this. Then this one should be inside the squiggly brackets. It's supposed to be pipeline name. Let's use one for data validation. If for pipeline name started, then model trainer, then you can just say pipeline, then you can just name this pipeline model trainer pipeline main logging, and again use this. You can say logging info, pipeline name terminated successfully. That's okay. Then we update our main.py. So main.py, we're just going to copy this and paste it here. Component, that is the data, not this is a model trainer component, then flogging.info component name started pipeline. Instead of data transformation, supposed to be model trainer pipeline. So model trainer pipeline, and we need to import the model trainer pipeline. So again, from src dot electricity bill dot pipelines dot model trainer 3 for model trainer. I'm going to import no, what are we importing? Data transformation model trainer, supposed to be model trainer pipeline. So component, model trainer component, logging info, raise exception. I think up to here everything is okay. So there's only one way to confirm if everything is okay, and that is executing the main.py file. So Python main.py. So this will tell us if our model trainer is working okay. Then after this, we can just push our code to the Git repository. Let's see. Going to take some time. Going to take some time, but everything, yeah. Remember, when running the main.py, remember we are starting everything from the beginning. Okay, that's why it usually takes a little bit of while. But model trainer component terminated successfully. Model trainer component started. Yeah, so everything up to now is okay. So we can just use a new terminal to push this code to the Git. So say GitHub, nope, git add dot, then git status to check which files we are pushing. So these are the files. So we can say git commit -m, then we can say model trainer complete. Model trainer complete. Then after this, we do the git push. So git push -u origin to main. Git push -u origin to main. Git push -u origin to main. So completed 10 locals. Yeah. So let's see if you are going to get that from the git push. So this is the link. This is the link. So we did the model trainer component. So the model trainer component. So src, you can see the model trainer component is okay 1 minute ago. So electricity bills, model trainer. So if you check at the pipelines, so model trainer, so you can see this is the code itself. So everything is okay. So we have updated the Git. So this is all about the model trainer. So once again, you can take time to go through and see text and conceptualize these the different concepts here. So this is the model trainer, and I'm going to close the session at this point. Then the next step will be about the model evaluation. Once again, I'm very grateful for your time to take time to watch this video. Also, before we sign off, again, please consider subscribing to this channel. Hit that notification bell. You can also like this video, share it with your friends so that they can also learn how to do this, how to build a machine learning model end to end. Once again, thank you and see you in the next one. So what's up guys, and welcome back. So we are going to continue with the series. Now we are at the model evaluation. in the previous video, we did the model trainer. So we were able to train our model. So that's what we did in the previous video. So you can go through that and see how we were able to train the model itself. So after training your model, then obviously the next step is all about evaluating your model to see if your model is making accurate predictions. Okay, so basically that's what you're going to be doing, and that forms the session for today. So before we get started, again, please consider subscribing, and also you can also like the video, share, comment. We highly appreciate that. Okay, so let's get started with the model trainer. So up to now, I think now you've started to gain our workflow. So the workflow is not from the data ingestion, validation, transformation. I think by now you have conceptualized the workflow that we are taking. Okay, so as usual. So for the evaluation part, I'm just going to be going a little bit fast because I'm fully aware I'm fully confident that you have been following through and you already understand the different workflow. So again, we're just starting with our entity. So this is the model evaluation configuration entity. And for this entity, mostly we are only confirming we are setting the file paths. Okay, so for the model evaluation, so let's set the file path for that. So for our model evaluation, this is the root directory. So our model evaluation, the test data path, you can see is this. The test target variable, you can see the y-test. So the test data path xtest transform.joblib, the y-test for now doing the testing. Then we can also infer, we can also see the model .joblib for that. And we also included the metrics file. So for the metrics, this is a regression model. So we have the mean squared error, the R squared score, the mean absolute percentage error, all those. So all those metrics and their values will be creating a new file, the metrics file, the metrics.json. So it will be a JSON file, and from there you will be able to get the different evaluation metric scores for those evaluation metrics. Okay. So this is the config.yml file. So we have set the paths for the different files. Then after the model evaluation, then after that we need to set the configuration manager. So for the configuration manager, so we start by importing the necessary files for that. Then we can just import the configuration manager. So this is the configuration manager for that. So remember the different file paths, the schema, params, and all those. Okay. Then we need just to import the configuration manager. It's the method for model evaluation. So whatever you're seeing here is just the same things that we have listed here. Okay. So this is the get model evaluation config. So we can also explain this. So for the model evaluation config, so this class is responsible for creating and returning the model evaluation config object. This object encapsulates the necessary configuration for the model evaluation, including the different paths that we are taking, the test data, the target variable, the model parameters, as well as the different metrics, as you can see. So this is the background for the selected code. So the get config, this is defined, which takes no argument and returns the model evaluation config as an object. Inside this, we have inside this method, the configurations, the different parameters, the schemas, and are extracted from the class attribute self-config, as you can see above here. Then we create directories for those. Then the model evaluation config is instantiated with the extracted configurations, parameters, and the schema. The target column name, as you saw, the target column name, we are obtaining that from the schema name. Okay, this code snippet demonstrates how the configuration manager class manages and provides the access to the different configuration required for model evaluation. Okay, so you can, I'm using tab 9. So tab 9 you can use to try to explain your code. So you can test your code, explain the code, if you want to document your code in terms of providing comments or the different comments or what your code explains. So you can just click on the document and you can see the different comments, and you can also see an explanation about the code. So for this case, you can see this method is responsible for creating and returning the model evaluation config objects. It retrieves the necessary configuration parameters and all that. So from here, you can just gain an understanding as to how this model evaluation is working. So after this, we create the class that essentially does the required tasks. So from here, I'll just copy the code. So from here, just copy that. So I'll start by, this is the class model evaluation, okay? Then we are doing our predictions. So remember in the previous video, we did the training. Now we are doing the predictions. So in terms of the predictions, we are using the XTest transformed. Then we are a ypred model.predict. So remember, model is in our artifacts. This is the model itself. So we're just recalling our model. So model.predict, then XTest transformed, okay? Then we are returning the predictions. So in terms of the model evaluation, we are using the ytest and the ypred, okay? Then this can be the ytest and the ytest and y prediction. So ytest, you know where our ytest is located. So I think we have defined that in the config.yaml file. I think this one, the ytest. So we have specified the path for our ytest. So we are just, ytest is considered as the ground truth, okay? What is considered to be the correct value, because that is the value we have in terms of sampling and all that. That is the true value. Let me use that. Ytest is the true value, and ypred is the value that is predicted by our model. So in terms of the mean absolute error, we are trying to find the difference between the true value ytest and the predicted value. Mean squared error, we are just, I think we square that difference. So by squaring, yeah, I think mean squared error, we are trying to square that difference. The R squared score is the test for variance. Then this is the root mean score, square root of the MSE. Then the mean absolute percentage error. So that is, we're using the mean, and this is the formula for that. So all these modules, I think we have imported them. Yeah, these are the metrics for our model evaluation. So once we are done with the evaluation, these are the things that we are going to return under this method. And after that, remember I said we are going to save our model evaluation, those parameters, the scores for the different evaluation metrics that we are using, okay? So we have created a method, save the results. So in the results, we are going to return the results, the ytest and the ypred. So this, let me this one here. So these are the results, the mean squared error, MSE, R squared, RMSE, and MAPE. Then we are going to save the results in a local folder. So we created a folder, this one, the metrics.json file. So this metric.json will contain the metric as well as the value for that metric, okay? So that's for that. Then after that, we go to our pipeline. This is how we are going to execute the pipeline. So remember, when we talk about a pipeline, simply what we're just saying is we are defining the sequence of execution, okay? So that's the importance of having a pipeline. Okay, so you can see the model evaluation is just very short. It's all about evaluating our model, seeing if our model is making correct or accurate predictions. Okay, so this one is for a regression experiment. I will also find an experiment where we are dealing with a classification example. I think it would be better if I tackle a regression example, see how the code looks like. Then we switch that to also a classification example, also to see how we are able to do that, so that I think at least you have an understanding of the both techniques. Okay, so this is that. So after this, let me just execute this. Let me execute this. So I'm just going to say Python. Then I'll just copy the relative path for this. Copy relative path. Then I'll just paste in the terminal. Then we execute. So the output will be will get a new file under the artifacts folder. That artifact and that folder will now contain the different metric, the evaluation metric, and the value itself. So then from there we can see if our model is performing okay, or we are having challenges with our model. Then from here, I think I'll do another regression problem. We are having another challenge in the target column. I think in this we don't need the target column. I think, let's see what error we're getting. Key error target column. Schema.name. Let's try to comment it out. So let's see if we're going to get evaluation.py. I think we're having a problem with the with that. So we are missing one position argument, the target column. So what we need to do, this one here, we also need to comment this out, target column. So let's you can run this file again. So let's save this. Then execute this again. As I said, we need to get the model evaluation. Model evaluation config object has no attribute target column. Is something we need to model evaluation why test is target column. So we were getting an error. You can see that the config box object has no attribute target column. So you can see the column key error was target column. So initially it was a wrong spelling. So target column. So it's supposed to have an N. So I had forgotten to add that N. So you need to be very careful with those spellings. So for the target column, you can see we have now corrected that. So this is the target column. And in our model evaluation, also make sure that the target column are named correctly. So I think that was the error that was generating that error. So that was the mistake that was generating that error. So I think I have corrected that. So I'm going to execute this model trainer again. So let me use a new terminal. So new terminal, then model evaluation. Just copy the relative path. This one is Python. That's the path for that. So I'm going to execute this. So when we execute this after correcting that error, is that we have, under the artifacts folder, we need to get a new folder, and that folder will be model evaluation, and that model evaluation file will contain the metrics as well as their respective value. So from there it's when we are going to see if our model is performing is making correct predictions. Okay, so there for different we are using different evaluation metrics because different evaluation metrics have or they display or they show different type of information. So that's why I have listed almost all evaluation metrics that are necessary when we are dealing with a regression problem. So we have the mean squared error, the mean absolute error, the R squared, the RMSE, and the MAPE. So with these different evaluation metrics, you are able to, depending on your model, depending on what you will be looking in terms of evaluation metric, then from this you are able to see and gauge which one you will be using. So I think you can now see that it's now working. So we corrected that error. So we corrected that error. So you can see now we are saving our results in a metrics.json file. So in the model evaluation, we are having the metrics.json file. And in this file, you can now see the different evaluation metrics. You can see for the mean absolute error, 1.8, mean squared error, 96. For the R squared, we are getting a value of 0.99. Root mean square is about 9.8, and the mean squared error, mean absolute percentage error is about this, about 5% deviation in terms of our predictions. So you can now see that how we started our model. So if we go to how we were building our model, so you can see under the model training, let it just load. So you can see, so I want to compare what we got from building our model, okay, in a Jupyter notebook or something like that, and compare that with what we are getting when we look at our evaluation metrics in the JSON file. So let me see. Let's see if you can get that comparison and see if you are way off or close. Okay. So let's just wait for it to load. Python this electricity prediction. So don't know why it's taking some time, but this is the file itself. I don't know why it's taking some time. Huh? Anyway, if you go to the first, I think it's the first video. If not the first, I think it's the second video before the data ingestion component. Before we did the data ingestion component, I showed you how these evaluation metrics are working. Oh, we are getting it. So let me just do this. So I'm most concerned about the decision tree. Let's go to that of the decision tree. So this is the decision tree. So you can see we are getting a mean absolute error of about 1.83. So when you go to our metrics.json file, you can see it's about 1.85. So we are not badly off. So you can see R squared of 0.999, 0.999. So there we are almost the same. For the MAPE 0.054, here we are getting 0.054. We're almost the same. So mean squared error is about 94. Here it's about 96. So there's a slight increase. Here we're getting an RMSE of 9.73. Here we're getting an RMSE of 9.81. I think there's a slight deviation in those. So you can see there's a slight deviation in our metrics compared to how we build a model, but maybe we can say that is negligible. Okay, it's insignificant. You're almost getting the same values for that. Okay, so you need to also confirm and make sure that after you have done your model evaluation, you're almost getting the same values as the way you are getting during the building the model itself. Okay, so I think that's it for the model trainer. I think you're now having an understanding. If you're going to build your any project, then this is how you can do it. So we started, I remember where we started with building a model. Then from there we went to the data ingestion, data transformation, model trainer, and model evaluation. So before we close this chapter, let's convert this to modular coding first. Okay, so for the modular coding, let's start with the entity. So evaluation metric. I'll just copy the code for the entity. So this is our entity. So just go to the entity configuration entity and just paste it here. So this one is for model evaluation. Model evaluation, that's the entity. So I can close this. The metrics.json file. Yeah, this one. Schema, we updated our schema. So our schema was having a problem it was just a spelling mistake in terms of target column, the one that we are using in the schema and the one that we're using in our code itself. So after entity, we go to the configuration component. So configuration, and under the configuration, we are going to copy this. This one is already there. So we're just going to copy the data get model evaluation config. So configuration, then after this, we copy this. Ensure indentation is correct. Then model evaluation config. And just copy this, and you can add it here. So just add another comma, then add that. So model evaluation config. So everything, I think everything is okay. Everything is okay. So we can save that. So that's the config. After that, we go to the component. So the component section, under the components, we can create, so component, let me create a new file. This file is component number 4, so component number 5. That is all about model evaluation. So model evaluation.py. That's component number 5. So for the component, I'll copy all this up to and before the pipeline itself. So model evaluation, I'll just paste this here. Then you have to make sure everything is in place. Everything is in place. Are we missing anything? We are missing the path and save JSON. So path and save JSON. So we need to save JSON, this one here. So make sure to add this. Then model evaluation config. Also missing the model evaluation config. Make sure to include that. So under the components, that will be found in our entity. So from entity, we're able to import the model evaluation config, this one. So from SRC entity, this is supposed to be configuration entity. I'm not wrong, config entity, that's okay. Anything that you're missing, path. So from pathlib import path. So if you import path, so I think save JSON we have it, then path we have it, so no problem. Any other thing? I think no. So we can just save this. So that was all about our model trainer. So the next step is about, so we have updated our components, if I'm not wrong. So we have updated the component. The next step is about the pipeline. So we go to our pipeline. So in the pipelines, I'm going to add a new folder. And this is pipeline number 5. This pipeline we are going to add, so model trainer, we are going to add, that is model evaluation. So model evaluation.py. So we add, I'll just copy this, Control Alt, Control C. So I'll just copy this, and then we will just make some few changes. So in our pipeline, so that is the model evaluation pipeline. So configuration manager, we need it. We don't need, we don't need the data transformation. Model trainer, so this one, I think this one should be 05. Then instead of components number, model evaluation, model evaluation. Then instead of model trainer, we need model evaluation. Then pipeline name, model evaluation. So model evaluation pipeline. So this one is model evaluation pipeline. I think it's okay. So class model evaluation pipeline, that is okay. Then we need to define our pipeline. So you can just go back to our pipeline, this one here. So you can just copy this. So this is our pipeline. So this is the pipeline. And remember, joblib, so we need to import joblib. And we also import pandas as PD. So import pandas as PD, that's okay. Model evaluation, so for model evaluation, we also need that. So do we need data transformation actually? No. This is a model train. No, this is model. There's something we have. There's something that we have. I'll just go for the model trainer. It's something that I've done wrong. So we'll just go to model trainer. I think I'll just copy everything in this code. Copy everything. Then in the model trainer, this is supposed to be a model evaluation. Then this is supposed to be our model trainer pipeline. Model evaluation. There are some things I've included here that they're not supposed to be here. It's supposed to be our model trainer. So just close this. So model evaluation, we need to go back, model evaluation. So this is what we need. Control C, model evaluation. Then we need to copy everything here, not model trainer. So we have joblib. So we have joblib. So we're going to import joblib. Then now we are just going to import PD. No, import is supposed to be import pandas, yeah? Import pandas as PD. Any other thing? So model evaluation pipeline. Supposed to be model evaluation pipeline. Yeah. Is there anything that we are missing? Here you can say something like that, or we can return evaluation metric results. So in the pipeline .main logging info pipeline name, no problem, started. Then model evaluation pipeline, then pipeline main evaluation pipeline terminated successfully. Logging exception as E, that's okay. So is there anything that we are missing? Let's confirm. Configuration manager, model evaluation pipeline. Okay, so that's okay. Control save. So that's the evaluation. Then we go to the main.py. So model trainer supposed to be model evaluation component. Model evaluation component name started. Instead of model this one, we need to change model evaluation pipeline in our main.py model evaluation pipeline. Then we need to import that module here. So we can just copy. Okay, so again from src.electricitybill.pipelines.pip number 5 model evaluation trainer, import model evaluation pipeline. So everything should end with the pipeline. Put logging and all that. So logging is okay. Evaluation component is model trainer, evaluation, transformation, validation, ingestion. Anything that we are missing out? Let's confirm. I think we are okay at the moment. Then you can then run the main.py. So Python main.py. So let's execute the main.py. So with the main.py, you are able to execute. You have a single point where you can execute all your files. Okay, but for the research, so this research is all about experimentation. So you are trying to experiment the different components. Then when you are converting those to modular coding, you're trying to separate those, combine the different sections together, then have a single point, the main.py, where you can just execute everything. So when you see your code running like this, then just understand that you have done something wonderful. Okay, this is the dream of the different machine learning engineers, or the MLOps engineers. When you execute your code like this and you see that every component is running in sync, then model evaluation component started, model evaluation component terminated successfully. So let's try something. Let's delete the artifacts folder, and let us delete the logs folder. Okay? And then let us execute this code. Let me open a new terminal and let us execute this code from here. So Python main.py, just to be sure that everything is okay. So let's see. We need to get the same thing that we are getting in a consistent manner. Then that will tell us that everything now everything is running successfully. So we in a component, so you can see where we started by data ingestion. So this is the metadata for that. Then data validation, okay, data transformation, okay, model trainer, model evaluation. Then when you go to our artifacts folder, you can see the different artifacts and the objects themselves. Okay, model evaluation, model trainer. So I think your code is up to now. I think the code is running successfully. Okay, so we started with the different components. So we started building each component after component after the other. Then we have merged those components together into a single file in the src folder. So you see this src folder. So if you want to try this code, or if you want to share with someone else, then you can just share this src folder, because this folder contains the source code for your model itself. Okay, so even if we are going to use the Docker and all that, we'll be using that while targeting the src folder, because it contains everything in there. Okay, so I think everything is running okay. You can be happy for yourself. Then we can just add this to our GitHub. So git commit. So git commit -m. So we can say model evaluation complete. So you can just CLS. Just clear the screen. So git add, then git commit. So -m model trainer complete. So that's okay. Then that's the commit. So git push -u origin main. Again, that is working. That's okay. You can see it's working okay. So we can go back to our code. And go back to our, let's refresh. So when you refresh, you will see the data, model trainer, model evaluation. So this is the central repository. So you can clone this folder and then you can execute it in your local machine. So you can see everything is okay for the pipelines. When you look at the components, you can see the different components. Okay, so what we are remaining with is building the prediction pipeline. So in the next session, we'll build the prediction pipeline, and after the prediction pipeline, we are going to build. We are going to use. We are going to build a web application. Yeah. So after the prediction pipeline, we build a web application, and in this application, it will be now at this point, at the point where we build the web application. This is the point where the user will now be able to interact with the model itself. So this is just the back end stuff. So that will be the front end application. With that application, the user will now input data. Then from there, the user is able to get an output. The output will be in form of a prediction of the monthly electricity bills. Okay, so that will be the next session after this. Then we look at either deploying our model, containerizing our model, maybe using things like the Kubernetes, things like Kubeflow, DVC if we get time for that, MLflow again. So we'll see how we can integrate those tools up to this point. Okay. So once again, I'm very grateful for your time, for taking time to watch this. I'll appreciate if you subscribe to the channel, hit that notification bell so that you never miss any of our video updates. You can also like this video, share it with your friends so that they can fast track their learning process in machine learning. With that said, enough said. So take time, go through this code, see if you can internalize them, and see. The goal is to just get the concepts, okay, so that you can apply the different concepts. You can apply the same concept, or just change or tweak a little bit of things here and there to ensure that your model is running successfully. So I'll see you in the next one. Bye bye. Hello everyone, and welcome back. So we are going to continue with the series. In this series, we are trying to build a machine learning model to predict electricity bills. So we started with the data ingestion, data validation, data transformation, a model trainer, as well as the model evaluation. So those were the different components in our model. So in the previous video, if you have watched them, you can see how I tried to build all those components and try to sync them together so that they can work in tandem. So in this session, we are going to start building the prediction pipeline. So the prediction pipeline, the main function or the main objective of the prediction pipeline will be to take the user input. Then from there, it will try to pre-process the data that the user has. It will try to process the user input. Then after that, it's going to make the inference. Inference is just another way of saying it's going to make predictions based on the user input. So the prediction pipeline will be tasked at handling that flow of data. So with the prediction pipeline, then comes with the also with the web application. So to add on the prediction pipeline, we are going to use, or we are going to add the web application. And for the web application, we are going to be using a Flask. So we can build a web application, and this web application will be as an interaction interface where the user can interact with the model. So it is through this that the user can now input data, and from the data, the model is able to make predictions from that. So that's what we're going to be tackling today. So before we get started again, please consider subscribing, share this video to your friends. You can also like this video, comment also, because we would like to hear from you. Once again, I'm very thankful for your time. And with all that said, let's get started. So as usual, we're going to start by first importing the necessary libraries or the modules for this for the that will enable us to build this prediction pipeline. So for example, the NumPy, pandas, the pathlib, because we are going to use import because we are going to access different paths. Then the OS, the sys. Okay, so we're going to use different types of libraries for this. Then we can also import a logging. Then I will also create a custom exception that will enable us to handle any sort of errors that might arise when constructing this prediction pipeline. So I'll from src. So remember we created exception.py. So currently the exception.py is empty, but we'll just fill it later. But let us just import the module for that. So src.electricitybill.exception. So here we are going to import file operation. So I'll show you how we are coming up with this. So file operation error. Okay, so import logging, file operation error, and also we are going to import the load object. So that utils, so utils dot commons import load object. So with the load object, so when you go to your utils, so utils in the utils, the commons, we have the file load object. So we are going to use this to load our any file, any joblib file. Okay, that's why we are using that. So we are using this function to load a joblib file in our prediction pipeline. So we'll be using that one, that function. So after this, we are going to create a class for making the predictions using the trained model. So create a class to make the predictions now using the trained model. So the trained model. So essentially, so class can say prediction pipeline. So class prediction pipeline def in itself. So here we'll just use pass. Then we are going to make the method that is going to conduct the actual predictions, where we are going to define the necessary paths and all that. So def make predictions, then self, that's okay. Then features. So features, remember, these are just the column names or the columns in our data. So here we are going to, I'll use the try block. So this try block will only be functional only if we construct or we make our own custom exception. So I'll show you how we can handle that. So here we need to specify the model path. So for the model path, so os.path.join. So artifacts model trainer, then model.joblib. So this one's supposed to be under quotation marks to define that this is a path to a file. Oops, model trainer, again we include this. Model.joblib, again we include this. Then we can also define the preprocessor path. So preprocessor path. So remember that os.path.join. So our preprocessor, again, I think it's just in the same artifacts, then a model. So artifacts, I think this one is in the model trainer. So when you go to the artifacts folder, artifacts, so if you want to find preprocessor.joblib, then or you can just copy the relative path. And when you paste it here, so we have the artifacts, we have the data transformation, then we also have the preprocessor. Okay, I just do like this. So after this, we need to now load the train model and the preprocessor. Load the preprocessor object. So preprocessor object, load object, file path. This is the file path, and we also need to load the model itself. So load the trained model, then model.object, that's file path, model.file path. So remember, as the user input comes in, it has to be preprocessed first. It do not just go directly to make the predictions. So it has to be preprocessed initially, so that as the way we preprocessed our training and the testing data. So it has to go through the same preprocessing. Then after the preprocessing, then it goes, and now we use the trained model to make the predictions. So that's why we are calling first our preprocessor object to do the preprocessing. Then after that, we use our trained model to make the predictions. So the transformed features after the preprocessing object. So we can say, just name this features transformed. That is the preprocessor. I will just use the preprocessor object, then transform the features. So the features. Then after that, we make predictions. So predictions model will predict features that were transformed. Okay. Then after this, we need to return the predictions. So I think everything is now okay. Then after this, we need to make our exception. So exception as E. Then we are going to exception exception as E, then exe. Then here we can say file operation error, then E, Cs. Okay. Now let's go to the exception.py, and we build our own custom exception. So under the exception, so again import sys. So import sys. Then we define the function that will extract the error message detail. Method to extract error message detail. Extract error message detail. So here if error message detail. So this is supposed to be error message detail. Then our parameters will be the error, then the error details object. Object, we will be using a sys. Just do like this, sys. Then this is the method itself. Then from here we are going to get the testback information. So get the traceback information from error detail. So here we'll just skip those because they are irrelevant for this case. So I think this is the execution testback. And then we call our error message detail. Error message detail. Error details, supposed to be error details object. So error details object. Information, so that's okay. Then after this, we need to now extract again the file name from the testback. Okay, from the traceback that we are raising. So file name supposed to be underscore tb. Then let's go frame f underscore code. I think that's okay. Go file name. So that's the file name. Then after this, we create a formatted message. error message. So from the formatted error message, it will contain, so we can say formatted error message, and this it will contain the file name. So it will contain the file name. Let's include these brackets. Then it will also contain the line number. So we can say line number. So the line number this will contain in this. Then I can just include a square brackets. Then the error message itself. Okay, so error message, that will be the error, and I'll just include the square brackets. Then you can return the formatted error message. So I think that's it. So if you want to explain this code, or if you want to learn what this code is doing, you can just click on the explain. Then you'll get a message on this taskbar, and you can get further details as to what the code is doing. So the selected code is a function named error message details that takes two parameters: the error representing the error message and the error details object representing the Python sys module. This function aims to extract detailed information about the error. So that's why, remember, we are creating our own custom exception. So we are going to use this custom exception to enable us to raise any errors within our code, including the file name, the line number, and the error message detail. So you can see the function starts by us importing the sys module. Then it defines the error message detail function, which specifies the different parameters: the error the error representing the message, and the error detail object representing the sys module itself. So after we are using inside the function, we are creating other lines of code, and this the first one is it retrieves the traceback information from the error details object using the error details object execution information. I don't know if I'm correct in naming that. This returns a tuple containing the exception type, the value, and the traceback object. Then after this, the function then extracts the file name. As you can see, we have also included that in our error message. So the file name from the traceback using this, okay, that we have defined. Then it creates a formatted error message using an f-string formatting. You can see the message includes the file name, the line number, and the original message error message. So the file name, we are able to go to the exact file and see. We are able to see the exact file where the error is coming from. That's the file name. The line number, as you can see, we have the line number. So the exact line number we are able to pinpoint. Then the original error message, so the type of error message that it's raising. So we are able to read that message, go to the line number in a specific file to be able to correct that. And finally, we return the formatted error message. So that's what this function or this method that we created is or will be doing. Then, so we need to define our custom exception. So we're going to define the custom exception itself. So define the custom exception. So for the custom exception, we define the custom exception. So custom exception, so class, so that's where the name file operation error is coming from. So file operation error, so that's where it's coming from. So file operation error, then we need to include the exception. So exception is the exception. Okay, that's okay. Then we can create a def init. So the constructor, so def underscore init underscore. Then here we can say self a formatted error message. So the formatted error message. Then another thing is the error details object. So details object. Then from here we can again use the sys module. Comes in handy while constructing this. Then we can use a class constructor to set the error message. So we can say call a class constructor to set the error message. So that is it. So it's supposed to be class class constructor to set the error message. So super.init formatted error message. Then from here we can call the error message detail function. So error.formatted error message. So here we can say again error message detail. Then can include this into a brackets. So that is the formatted error message. Then error details object. And just error details object. We can use this. Try to squeeze this. Then so formatted error message detail object, error details object. You can just do this. Super, we're getting an okay. It's now correct. Then after this, we can then override the string method. So here we can override the string method to return the formatted error message. To only return the formatted error message. So override, supposed to be override. Okay. So after this, so everything self, then we can only return self.formatted error message. So this is how we can construct our own custom exception. So for this, again, we can explain what is taking place. So the selected code within the open file is part of the init method of the file operation error custom exception class. This method is responsible for now initializing the custom exception object with the formatted message. So you can just read through and find out what this class is doing. So overall, this code snippet demonstrates how to create a custom exception class in Python that includes the formatted error message along with additional information such as the file name, the line number, and where the exception occurred, as the way we discussed earlier. And for this, we are just trying to skip. So the string method is a special method in Python that is called when the object is converted to string. So in this case, it is used to return the formatted error message that was created earlier. So this one here. Okay. So by overriding this method, the file operator error class can only provide a custom string representation of the error message. So we created our own string, and that's what we want to be returned when we are going to raise an error. So that's why we are trying to override what is the custom. So by that, we are making it easier to print and log the error details. Okay. So we can try our custom exception to see if it is working. So let's let's try to raise an exception. So if __ main, then we need to include logging. So again, from src.electricity bill, we are going to import logging. Import logging. So logging division by 0 error. So let's try to see if you're going to get an error. So I'm going to execute this file. So we create a new terminal, and in this terminal, so Python, then exception, copy the relative path, then just paste in the terminal, and see, you can see we are now raising this error division by 1. Then if you go to the logs, I think this one here, you can see we are now raising this error, info division by 0 error. So you can see our error is working. Our exception, our custom exception is working. So I think we don't need this. So we just need this if we are trying to raise a custom exception to see if our exception, our custom exception is working. As you can see, it's now working okay. So going back to our prediction pipeline, you can now see that we are able to raise the file operation error, where it's coming from, object where it's coming from. We can also maybe include a logging message. Can also include a log message, logging info, making predictions. Then we could also include another one here. So prediction pipeline. So after this, then the next thing, we are going to create class for custom data. Create a data class to represent input features. So we're going to create a class to represent the input features. So the input features are just the input features are the columns in our data. So class can say class custom data. So custom data, def init. So for def self. So here instead of listing all the columns in your data, you can just use the quags. So remember the args and the quags when learning Python. So from here, you can just initiate the attributes using the quags. So initiate the attributes using quags. So this one is saving us the hassle of typing all the input features. So you can say for example, for key value in quags dot items. So they are in something like a list. So items. Then from here we need to set the attribute, self, key, and value. That's okay. So we can do away with this. Then after this, we need to again define another method. So define a method to convert data object into a data data object to a data frame. So the custom data features, again, if you explain this, let's see what it's telling us. As custom data, this class is designed to represent input features for machine learning model. The init method of the custom data class, the code uses the quags parameter to initialize the attributes of the class. The quags parameter is a dictionary that allows you to pass any number of keyword arguments to the function. So as you can see, it's preventing us from listing all instances. Okay, so inside the init method, a loop is used to iterate over the items in the Quarks dictionary. For each key value pair, the code uses the set attributes function to dynamically set the attribute of the class with the corresponding key and the value. So by doing this, we are able to create an instance of the custom data class and pass any number of attributes when we are initializing it. Okay, so it's essentially, if this word jargon is quite hard to understand, just know that we are not trying to list all the attributes here. We're just using the Quarks to enable us shorten that process. Okay, because with the Quarks we are able to list any number. As you can see, we are able to list pass any number of attributes when we are doing the initializing. Okay, to define them. So get data as data frame. So you can say here get data as a data frame. So after we get data as data frame, so get data as data frame. So self, again, we initialize our try block. So here we're just going to log message, convert the data object into a data frame. So data key and value pair comes in form of a dictionary. So so here we will specify let's say the key, then get the attributes, self comma key. Then from here you can say for key inverse self, that's okay. Then after this we need to convert the dictionary to data frame. To data frame. Or instead of I just do this in the return method, in the return. So here we can say so return pd data frame data dictionary. Okay, so to minimize writing an extra code. Then in terms of exception, you can just use this one. So this can just use the exception. So this is the prediction pipeline. This is so when we try to explain this, so this class is designed. So this class is designed to represent input features and provide a method to convert the data object into a pandas data frame. Okay. So we are converting instances of the custom data class into a pandas data frame, handling potential exception and logging the conversion process. Okay. So the these two methods are working simultaneously. So let me just do this. So that's it. So we have successfully built our prediction pipeline. So let's go to the app now, app.py. So here, from here, we can now start a web application. This is now where we start building our web application. So I'm going to import the necessary libraries. So from Flask, import Flask request and render template. Then we also need import OS. We also need sys, so import sys. And also import necessary libraries. So again, from src.electricity bill so we are going to import our prediction pipeline. So for pipelines, tip number 6, prediction pipeline. We're going to import custom data. Supposed to be custom data. So supposed to be custom data. So that's okay. So exception prediction pipeline app.py. So it's supposed to be custom data. So that's the prediction pipeline. Then we can also import the exception. So again, from src, our custom exception, that is electricity bill dot exception. We're going to import file operations error. So after we're done that, we can now start creating our Flask application. Create a Flask application. So application, you can call it Flask. Flask name. Then you can just call up application. Get the Flask app application. That's okay. Then we can create a route for the home page. Route for the home page. So with this, you can say so app.route. Then that's it. Then instead of home, you can use the index. Then from the index, we can return a render template. So render template will be our index.html. So ensure that we have the templates, a folder called templates, and in the folder templates, we have the home.html and the index.html. So the index.html just contains a message like welcome to homepage, so that when we call this, then we are going to, when we return render template.html. So I'll show you the first way what we can do at first render the index.html. So some form of message like welcome to homepage, something like that. Then so this is the route to our homepage. Then we can also create another route. So the route to train the pipeline. So if you just want to train the pipeline now from the app itself, so you can use this. So app.route. Then here we're going to train. So method I think we'll use get and not only use get. So methods get, then def train if request. Then here we can use another. So you can say os.system, then say Python main.py. So remember our main.py. So when we are just going to train our pipeline, we're just going to call this method main.py, and the training instance takes place. Then after this, we are going to return something. Return maybe a render template index.html. Let's return a message. or you can render another template. Let's say, let's create a new template here. So let's create a new file, and this file, let's say, call this train.html. okay, so train.html, and then in the train.html, what we are going to do is we just copy such a message into our train.html, and then we can say training successful. You can just check the spelling. Okay, you can. So when we do the training from the web app, then and so when we do a slash train, then we are going to render the train.html. So train.html file, and this, it will display the message train successful, training session successful. So that's okay. I can just do away with this, and then after this we create one for prediction. So route to predict the pipeline, then app.route. So this one is for the prediction. So when for the route.home page, so again we try to explain this. The selected code snippet is part of the Flask web application, and this code snippet a route is defined for the home page of the web application. So we are creating this is the decorator that specifies the URL route. Then index, this is the function which will be executed when the route is triggered. So when we trigger this, then we are going to use this method to trigger to execute, and the function name index is a conventional name for function that handles the home page of the web application. Then we are going to return something. So this line code uses the render template function from Flask to render the HTML named index.html. So from there, it will now display the message that we've specified earlier. The same thing happens to the training pipeline. So again, this route is possible for training the machine learning pipeline. So remember, we had the main.py. So the line defines the Flask route that matches the URL path train that accepts a GET request. So this one again is the function that will be executed when the GET request is made. And after that, we have this. So this line uses the OS systems function to execute the command by this one. So after this is done, after the training is done, we are going to return some message. So this line returns the rendered HTML template, this one. So the rendered template function is a built-in, okay. The selected code snippet uses the Flask routes for the training machine learning pipeline. When the GET request is made to the train endpoint, so the train function will then be executed, which runs the main.py, as you saw. So the main.py is our main point where we can execute the model itself. So we are going to use that to train skip to train the pipeline, and then returns the rendered HTML template for the training process. Okay, so now let's complete this by creating the route that will enable us to make the predictions. So up to route predict method. So for the predictions, up to route predict method post. So here we'll use the get and the post. So get. So get comma post. So diff predict. Predict and data point. Data point. So def predict the data point. That's it. So then we need to include some function here. So if request dot method, then is for get, then we are going to return render template home.html. So we are going to return home. I'll show you what is in the home.html file. Else, so from the else block, we are going to now include our try block. So else like this, then try if. So we first need to so try block, just do away with this. So in our try block, so the first thing is we are trying to initialize an empty dictionary to store the data. To initialize an empty dictionary to store the data. So inside here, so we are getting something like a form data. So that's supposed to be a dictionary. Remember to use the squiggly brackets. Then after this, we need to iterate over form fields and populate the dictionary. So in this case, so you can use a for loop for field in. So inside here, we're just going to paste all the column names. So fan, refrigerator, air conditioner. So these are our features our features in our data. Okay. So tariff rate, all that. So after this, we need to. So for that, we are going to say form data. So form data field. Then here we can say we're going to get a request.form. So request dot form dot get to brackets the field. Then create custom data object using the quirks. So remember we created that. So to create custom data object, here we are going to using the quirks. So we can say something like custom data. So custom data equals custom data form underscore data. That's okay. Then after this, we need to convert the form data dictionary to a data frame. So remember the function that we are using in the prediction, this one, get data as data frame. So we are using that to convert the data dictionary into a data frame. So you can say read df. So we are going to use custom data dot get data as data frame. So create custom, okay. Then we can do some printing. So print the data frame for debugging process. So if you want to do some debugging of your data, debug as double G for debugging process. Then we can say print df. That's okay. Then another thing, you can use a log message. So log message at this point, we can say logging info from data say form data before prediction. Then what we can do, we need to import that. So we can say, yeah, from CSRC build import logging. So it's supposed to be logging we can use something else. Print, we can use message print before prediction. Let's see, just adding it so that it's able to tell us if we are so we are going to initialize the prediction pipeline. So prediction pipeline, prediction pipeline, prediction pipeline, prediction pipeline. Then we can use another log message. Logging info, that's okay. Here we can say mid prediction from data mid prediction. Then after this, we need to get the predictions. So make predictions. So we can say predictions, prediction pipeline, predict spread df. So prediction pipeline, this one here, prediction pipeline, make predictions. So we're using the function make predictions from predict df, this one here. Then we can also add another log message. So log message, logging info, and say after prediction, so that's okay. Then we can return results. Return results. So results we can let's say return render template home HTML predictions. Predictions. So prediction. Yeah, that's okay. Then after this, the accept. Exception as E. File operation error as E. So undo. Let's try to squeeze this. Nope. Let's try to squeeze this. Exception as E. Then let's try to run our Flask app. So if name underscore main app.run debug true, then we can use host and create our host. So 0.0.0.0, then debug be true. So this is our prediction pipeline. So I'm going to create. So from here, we are going to execute our code, and we want it to run from here. So we can say, let's say sklearn something like that. So we want to execute it from there. So we can save this. So now let's go to the home.html. So in this file, so you can this is the code, the HTML file. So you can see from the HTML it contains the different. So I did some styling here and there, and then you can see the electricity bill predictor. So a method posts. So the number of the number of fans, refrigerator, so the number of refrigerators, number of air conditioners, number of television, number of monitors, number of I think it's a I think it's supposed to be, let's say supposed to be electricity. Supposed to be cargo. I think it's this one. So what I don't think it's supposed to be number, it's supposed to be hours. It's a comprehensive, captures the electricity consumption pattern for Indian household. It includes information about the number of hours of each household appliance. So it's supposed to be number of hours. So how can we call this? Number of hours of each household appliance. Number of hours of hours. So number of hours. So we just change this. So you can use. So I suppose this is the number of hours this appliance was on. So month. In a month. So these are the cities, different cities. So options for the cities. Also, these are the number of the different options for the companies. So if you go to electricity bill, so let's wait for that. So monthly hours. So this is not number of month. This is supposed to be just month. The 10th month, the 11th month. Okay. So monthly hours. So you can say total monthly hours, tariff rates. Then we make our prediction, something like that. So in this case, number of hours of monitors. I'm trying to find a better word to describe this. Additionally, it compress. Okay, the rest is to predict. Number of hours funds in operation. You can say something like that. Number of the funds in operation. Of funds in operation. You can say number of operation hours. Number of, say, operation hours. Then you can just use this comma and just say, okay, something like this. Number of hours. So funds, number of hours number of hours for the refrigerators. Okay, number of hours for air conditioner. Number of operation hours. Okay, number of operation hours for the television. Number of operation hours for the monitor. Number of operation hours for the motor pump. Month, just the month. Again, companies, just the company. Monthly hours, total monthly hours. Tariff rate, tariff rate. Then we create a button to predict. Then the prediction like this. Okay, so this is the HTML that we are going to use this HTML to input data. Okay, I think everything is okay. Let's try to execute this. Okay, so let's see if we are going to get something. So I'm going to execute this. Let me create a new terminal. So a new terminal. From the terminal, you can say Python app.py. Just yeah, let's wait and see. So we need to execute this. Private network can allow access. Then we are getting this link. So you can just copy this and maybe open this. So we are opening it here. Let's see. So initially the 127.0.0.1 colon 500, it will be leading us to our homepage itself. So it will be leading us to our homepage. So our homepage, not the index page, something like welcome to our homepage. So that's what we are expecting. Let's just wait for it to load. So we're expecting it to lead us to the homepage. Homepage is the index one. So when we execute that, we are supposed to bring us to the index. We are supposed to see some message like this: welcome to homepage. What's something, as you can see, we are getting the welcome to homepage message. So you can see our app is working. So if we want to train our model, so remember when we create the route to train the pipeline, so we can include a slash train. So when we include the slash train, we will be training our model. So let's execute that. So this is going to send a request, and in that request we are going to train our model. In that request we are going to use this. We are going to execute this Python main.py, and once we execute the main.py, you will see that we are will be training our model. So let's just give it some time for us to train the model. Then after we train the model, I'm going to try now to do the prediction pipeline. So after we train the model, we need to get some message. The message should be the train HTML, training session successful. So that's what we should be getting. I know it's taking some time, but we just give it some time for it to complete. know why it's taking some time, but let's be patient. As you can see, you're getting the message. Training session that was successful. So I think our model is working okay. So you can see the training that was taking place in the background. So this is the training that was taking place. Okay. So you can see this. So let's try now the last part or the last bit, which is all about now how the user can interact with our model. Now we use the /predict. So this one will render the templates that the user will now use to make the prediction. So /train, so predict. You're going to get such a thing. Okay. So from here you can insert the number of hours. Let's say insert 2 operation hours. You can say, let's say 15. The number of operation for air conditioner. You can say 22. Number of operation television. You can say, let's say 5. These people don't like watching television. For monitors, again, you can say 5. The number of operation for the motor pump, you can say maybe 1 hour. Enter the month. So month, for example, you can say the 5th month, or the 5th month, which is May. Then city, you can let's say you can try New Delhi. Company, we can say Torrent Power. Monthly hours, we say 389 hours. Tariff rates, we can say 9.48, something like that. So let's see if you're going to get our prediction. So when we execute the predict button, again, it's going to take our data. Oops, getting an error. By operating this, getting an error somewhere. Let's go back. So this one will tell us where we are getting the error. Press back. Response. So error modules is so we are getting an error after mid prediction. Object transform features. Object transform features. Let's see why you are getting the error. Try to do this. So pred-df. So custom data. That's okay. From data, pred custom data dot get data frame. Okay. So we forgot to add that thing there. So I don't think this is the problem. So the challenge was coming. Error module info making predictions. Error. So after making predictions, info making predictions. Okay. So we forgot to add this from data prediction. So before prediction pipeline. Prediction pipeline. Make prediction spread df. Okay. And logging, no problem. And template home.html prediction. Then can add something like this. So let's see. Let's try it again. Let's run this. Make sure you have saved. Then just clear the screen again. So open the new terminal. You can say Python. That is up.py. So let's see. When we run this again, we're supposed to use this. So I'm going to execute this again to this. Then we're just going to do /predict. So we are going to do /predict. It will bring us to this page. Number of funds. So number of operation hours for the funds. So this one you can say Let me not try to shoot over and beyond. Fun, we can say 16, it's around 23. So for the fun, we can say 16. Let's use 12. Number of this one 23. Let's use 25. Then for air conditioners, let's use it's about 2.0. Let's use something like 5. For the number of operation hours, for the television, let's use 8. Number of monitors, let's say monitors, we can say 7. Pump, let's use 1. Month, the 5th month. City, New Delhi. Company, we can use Unitech. Monthly hours, let's say 390. Tariff rate, let's say 7.8. So you can just use arbitrary numbers for that. Let's do again the prediction. Don't know why you're getting error. So tariff rates, we are prediction. Predicts, why are we not getting the output for that? So you can see fund prediction, New Delhi transmission, power 897.8 tariff rate. This is the output for that. Logging info form data mid prediction, making predictions, form data after making predictions. This after prediction, post prediction. This let's see. Let's try to format this HTML file. So format HTML file online. HTML, let's paste file here, use for format. And just copy this, then go to our file, home.html. You can just paste this here. Then we can run this file again. So Control C. Let's clear the screen. Now we can say, after we save this, you can say python app.py. This is always a tough challenge. Always a tough challenge in this section. Then I will use this, and then it will bring us to this page. So after that, we do a /predict. dash predict number of hours. This one you can say number of fans. Let's say 4 refrigerators, 5 number of air conditioners, 12 number of television, 7 number of operation hours of monitors. Let's use 0. Use 0. Monitors. Let's use 15. Let's use 0, 5. Hyderabad, OptiBelt, number of hours, let's say 380. Tariff rate, around 7.8. Yeah, say 7.8. Okay, so let's again, you're not getting the output being displayed. Let me try something. Let me try to format this home.html. Don't know why we are not getting. We need to get the prediction. Need to get the prediction itself, but we are not getting that. The file is executing okay, but we are not getting the. We need to get the prediction. We need to get the prediction being displayed. Let's see what we are missing. So I'm trying to debug this code. Okay, so there's something that you're supposed to get results, and the results supposed to be prediction, if I'm not wrong. So prediction need to route correctly. So route predict method post, method get post predict data point. So if request is equal to this, render home.html. In the HTML, we need to ensure that predict method posts. So this one is method is post form action control find predicts. Seeing language. So viewpoint content with electricity bill prediction title style body, then electricity bill predictor. So form action. Supposed to be result. If result is this, if class result prediction bill result div. So we were getting an error. There was something that there was an error in terms of our method trying to display the prediction. So in terms of the error, I solved the error. Now it came in terms of I had the mismatch in terms of prediction. So I had I changed something also in terms of how we are going to display the message. So the prediction should be much in line with what we are trying to return here, the render template itself. So here we're using prediction. So make sure the same case you're using prediction. So from here you can now able to make the prediction itself. So let's try to execute this file once again and see if you are going to get the predictions. So I'm going to repeat this process again. I want you to execute from this tab. So in this section, I'm going Control C just to end this process. To end this process, Control C to stop the initial process. Then after this, what we can do, we can make sure we have saved everything. So this one is not needed, exception not needed. This one is not needed, exception app.py. Okay, so we can clear the screen, the terminal. Then let's execute this once again. So we can say Python app.py. So let's execute this, and we should get our link. Then when we try to access that, it will take us to a Google web browser. So from here, let's make sure that we are going to get our message here. So Indian, let's say, okay. So from here, we go to this link, then just control, then click on the link. Then I return home page. Then we can use the predict. So when we execute the predict, so number of fun hours, I like to be a little bit not to shoot very fast. Let's try inputting values very close to this and see if we can. Well, let's try arbitrary values. There's no need, not a must that we follow that. Number of funds. We can say number of funds. For example, we can say instead of 16, let's say 18. Number of refrigerators, we can say 25. Number of air conditioners, we can say 3. Number of television, let's say 7. A number of monitors, let's say 3. A number of operating hours for the motor pump, let's say 1. For the month, let's use 5, because we are in the month of May. For the city, Hyderabad, let's use Mumbai. Then for the company, let's use Orient Green. Then for monthly hours, let's do something like when they are predicting about 384, 500, let's say something like 420. Then for the tariff rate, let's put it at 8.1. Let's see, predict. We should be getting our prediction being displayed. So you can see the predicted bill amount is this 344.99 rupees. So the prediction amount is in form of it's in the Indian rupee. We're using data from India. So you can see now that we have done our prediction. You can see that by just inputting data onto our web application, we are able to get some some predicted amount based on the input data. Okay, so you can see you're getting this prediction. So this actually now you can see how we can actually now you have I assume that you do have an understanding of now building a machine learning model from just now from just a simple model that we had in our Jupyter notebook. Okay, just a simple model like this one. Where was it? The decision tree regressor now. So actually, all that we have been doing is we have been building the infrastructure around this code. That's what we have been doing. So from a simple model like this, we are able to construct something like this, where we have our web application, and from the web application, we are able to get the prediction based on the input data. So this is the web application. You can practice all along. Try different values to see what prediction you will be getting. So I think by now, I assume, or I'm quite sure that you have a full understanding of how to build an end-to-end machine learning, depending on the different, depending on the data that you are doing, or on any project that you are doing. So this is something like the basis of it. So you can use this now to try to add other things into your model. Okay. So you can now see that our model is working. If you try, if you, for example, try to execute the home page, you can see you're getting a result for that. When you want to execute the training pipeline, and if you want to make a prediction. So you can see now our model is now functioning. So the prototype part of it is now functioning. So whatever it remains is all about now doing the prediction, doing the deployment. So you can do the deployment in different, you can deploy this to a server. You can also display or deploy this to edge devices, mobile phones, or okay. So there are different ways or methods that you can use to do the deployment. But all in all, this is it for today. Once again, thank you for your time. Thank you for your patience in this journey while trying to build this machine learning model. I'm grateful for your time. So before we close the session, let's push this code to a GitHub repo. So I'm just Control C. Then we can do that. So add dots, git status. You can see the files that we are trying to commit. So we have the app.py, the exception, the prediction pipeline, home.html, index, and train. So git commit -m. So we can say web application complete, web app complete. Then we can do the git push -u origin main. Okay. So that's it. Now you have successfully built your machine learning model, and you can see that now it's now working. Starting from just a simple model, only a single cell in terms of code, up to now where we can have a web application where you can input your user data and you are able to get a prediction based on your data. So I'm going to end the session at this point. So if I will maybe I will add other things from here. Now the deployment part, we can convert our file into a container, so we can containerize this model using the Docker. We can also use the MLflow for I think MLflow for model I'm forgetting that word. So you can use the ML flow when you want to do data versioning. So for ML flow, if you want to do model versioning, you can use the ML flow. If you want to do the data versioning, now you can use the DVC and all other tools. So all other things come in terms of now when we will be doing the deployment. So I will be adding a little bits onto this model until all the way to deployment. So I'm going to end the session. Once again, thank you. I'm grateful for your time. Please, you can share this with your friends, with your colleagues. Please consider subscribing again. Like this video, and I would like also to hear from you, so you can write something in the comment section. Once again, thank you. See you in the next one. Bye-bye.